the walls are walks the line. There's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe is all view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie making power for days. Don't listen to a word that the straight dope says. Mike building batteries to power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plasma bolts a mile long. Sheila on the video making tones of the prongs. Bernie breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope and old man Bills.
Hello everybody and welcome. My name is Nathan, otherwise known as Old Man Bills. What's up, Joe?
It's Saturday, and boy, do we have an episode for you.
Nice. Love it, man. Love Fridays, man. Friday's a fun day.
Good time.
What's going on, everybody? What's up, Lightspeed? Hanging out with Dispatch, man. Chopping Fools hanging out, man. Cool show, man. We're going to have a good one tonight, too.
Right on.
So, heck yeah, man. CBK hanging out with us. Sent me some cool stuff, man. Really awesome. Some Organites go on Tesla coils, man. I got to get out that video for them and, show my appreciation. So,
right on, dude.
Also, Dennis got some videos out there, man. At some point today, we're going to have to take a look at them. He's got some cool stuff going on. So he's got some big coils out there, man, and he puts his hands on them, and then the lightning goes between his hands and the coil. Dude, it looks pretty sick.
That's very cool.
All right, Joe, you want to get into it, man? What are we talking about?
Yeah, I mean, we'll do the little warm up first, and I think I'll give a little preamble, look back a little bit to something that was discussed, and we've been doing this lately, looking back to the early days of Joe and Old Man Bills, and just going back to my nonsensical ramblings of how I think it works and all this sorts of stuff. And I think that what you'll find today, by the time we're done here, is that it's culminating in Nathan having his name now on a second physics paper.
It'll actually be my third, man.
Third? Oh yeah, right on, man.
Yeah.
So that's awesome stuff. But to kind of give a little bit of before I backtrack, kind of tell you what we're building for. So after all this discussion with Rav and the energy exchanges and how it builds the field and how it sort of isolates itself and then creates non-equilibrium states, what I realized is that these non-equilibrium states are, closer to simulated still potentials, even though the only thing that keeps them different than that is the fact that they have the exchange in the first place, right? And as we know, we see this four-dimensional element that exists in magnetic fields and also exists in a virtual projection when we're dealing with the RAV, and we've identified this virtual projection as the high energy the high energy density state, basically the well where that high energy density state exists. So once you start to realize that, okay, you have this consistent factor of dimensionality being consistent with the high energy state, and the organization of things. And then you start thinking inside the box rather than outside the box, because what I often like to do is I like to look inside the box to think outside the box. Okay, and that's where my entire train of thought generally comes from. And we know that they describe the fourth dimension, right, as space-time. Well, gotta love that one. Well, I know I don't. I never really bought that for a second, but I agreed that there was a relationship,
Yes.
okay, to 4D and space and time. I knew kind of sort of what that relationship was, but I needed to kind of think about it harder and further in a logical way, okay, that allowed me to kind of dissect it. And what I kind of opened up when I came to the not end, but I came to sort of the pinnacle of this train of thought was that, well, we say time is emergent, but emergent of what? Right? We say that we can manipulate time and there's time dilation, but but dilation of what? What are you opening up or expanding or contracting? What are you doing, to this otherwise ambient idea that they just place off mathematically as another dimension? Well, I thought about it like I usually do, and I thought about it geometrically. What I came to realize is that phasing and geometry has a lot to do with one another, right? You could have one shape, for instance, in 3D space, and then the same analog shape in 4D space. But the thing is that the four-dimensional shape, okay, which would otherwise appear the same, okay, has planes that simply don't exist in 3 dimensions. That's what that comes down to. And that's how dimensionality works largely. You see, every dimension is made up of parts of the dimension below. So in 3 dimensions, we are made up of 2-dimensional planes and 1-dimensional points that fall into 0-dimensional points of rest, right? That's what we're made up of. I mean, it comprises our world. Well, 3 dimensions comprise a 4D world in quite the same way. The thing is that just like the 2-dimensional plane creatures don't exactly have access to the 3-dimensional world, but we have access to their world. And that's sort of the point, is this threshold, this boundary that exists. And physics has, in common form, it had all the right pieces. It's like buying a piece of IKEA furniture, you know what I mean? And just not looking at the directions and also not really knowing exactly what you're building, and they just basically assemble a handful of parts that they think goes together, leave the rest in bits and pieces, and then say, oh, well, this is kind of shaped like a chair, even though it's like, the leg and subsection of a table. Like they don't realize that no, it goes together as the table and it pushes that extra direction. And they hide this behind this premise of what type of evidence is empirical. Okay. But then they contradict themselves when it's convenient, when their equations don't work. So they'll consider certain things that in quantum mechanics that they can't observe to be empirically evident. Even when they're not, because it's convenient, because I guess the good thing is when you make the rules, you could break them too. But I think that the point here was that I found that there's actually ways, okay, to identify the mechanism of time, and then therefore gravity, right, and therefore space. And rather than sit there and define it as something entirely new and label it and give it some kind of unusual mechanism, I just looked at the parts that were there and put them together. That's it. So it doesn't break any laws. All it does is makes a handful of modifications, okay, to connect all of them. And it actually, so far, has simulated out flawlessly,
Nice.
which is all you could ever ask for whenever you're dealing with a theory, now, isn't it? So now that we've kind of touched on it a little bit, and I haven't told you what it is yet,
Okay.
okay, let's backtrack. So There's a point in time where I talked about this descent of energy to matter. Okay, and I went through what I postulated was all these dimensional phases, and I called them dimensions at the time, you
Mhm.
know, of higher order energy phases. Okay, which are actually, it's actually an inverse, which is kind of weird. It becomes most simple to more and more complex as the energy falls down. But then the energy actually does something weird, right? It falls down and then it gets to a state where it actually becomes matter, or at least a particle, a matter potential. And as soon as those potentials is the matter 0 point on what we would consider zero dimensions, start to accumulate, then they could form the second dimension, being, the two fundamental particles, which are just all the same shit, just not in a state of any sort of arrangement yet. Okay, you take your fundamental particles, once they become in relationship with each other, you no longer have zero dimensions of matter. Now you have one dimension of matter, a line, some kind of connection that's made, some type of relationship. And then as you double that into 4 points, then all of a sudden you have the ability to have four. So that's the start of actually what would be a simple lattice structure. And then you build that up one further. Well, now you have three-dimensional structure. Now stuff is starting to grow up and out, right? But the ironic thing is that all of this stuff just exists in 3 dimensions, not necessarily in relationship to anything else, because there's nothing to hold it together and there's nothing to animate it. So what actually ends up happening is, as the energy comes down and then the matter comes up, you see the matter is actually working up on the energy scale. And where it reaches its equilibrium, so to speak, if you want to call it that, okay, is at the threshold. And this is what I said at the time, and I didn't really understand fully why. I just understood energy as the animating force and the matter as the creating force. So I mean the physical creative force, right? So now I'm here to say that where we are is somewhere very interesting, right? So we're 3 dimensions, okay, and we sit at the threshold of 4 dimensions. Okay, and because, as I said earlier, all lower dimensions exist fully and wholly within higher dimensions. Okay, well, the four dimensions is constantly all amongst us, but we are only a very small part of it, is what it boils down to, and there's a much greater reach that exists. Okay, but like anything dimensionality, and you've seen it even here on the show, as you know, with matter, you could break the matter down in its dimensionality.
Mhm.
Okay. You could also break energy down in its dimensionality as well. Okay. Or you can build it up. Now, what do we know by and large is one of the biggest connecting factors here is magnetism. Okay. And actual magnetism. All right. And the reason for that is because it is 4 dimensional. Okay. But remember, we could only see kind of counter effects of its 4 dimensionality. All right, because it's a 3 dimensional object that's a projection of a 4D. But it offers an access point, okay, to that higher dimensionality. Now, when you take into consideration the relationship that matter and energy share, and how energy is only manifest in the presence of matter in the first place, and then you take into account how they consider mass to be what bends space-time. Okay, that's how Einstein decided to put it, was bend space-time. But is the reality of it very similar, but just simply different? Okay, that matter, okay, actually is the catalyst for energy transfer between the fourth dimension of a more pure energy state and our dimension. And is that relationship of that energy transfer the mechanism of time? And what I would say is yes, that the pressure, or so to speak, that we put on that threshold with matter and greater mass, okay, ultimately throws off the differentials. And like I said, energy always chases to destroy the matter. Well, the higher the mass, the more the matter, the more the energy has to come in exchange and bring matter back to it, right? That's the goal, is to loop it, bring it back to it, right? But on in doing so, the matter has now drawn the energy out. What's matter extraordinarily good at? Well, the opposite of what energy it does. If energy can break down matter and bring it back, well, matter can capture energy. And how does it do this? It does this through electromagnetism, the manifestation of electromagnetism, okay, and all the vectoring modes, and the fact that matter acts as an energy lock, okay? So there's a certain effect it has on natural entropic forces, okay, because what it's going to do is it's going to hold the energy up and try to capture it. Sometimes it does so chemically, which is diabolical, okay? When you capture energy and then you make it physically into matter and trap it as a high energy potential hydrogen, for instance, and then stabilize it with oxygen to make it basically that energy is trapped in a matter state at that point. So there's an energy lock differential that exists in this exchange. And what I propose is deterministic of the flow of time, or how time is perceived or passed, like how fast, is actually the exchange rate between the fourth dimension and the third dimension. And then there would be an offset amount of exchange rate that would occur. There's certain situations where the third dimension's pulling hard, taking, right? It's got to proportionally give it back, right? That's what we know. It's got to proportionally give it back in whatever that exchange rate proportion is. That exchange rate proportion seems to be tied to mass, which makes sense. And that's what we propose is actually the mechanism of how fast time actually passes. Now, where this becomes interesting is by the access, right? So the magnetic fields, right, are energy manifest in the presence of matter. It's this interaction with matter on a large macroscopic scale. Okay, and we know that they have helical flow patterns to them. Okay, and the helical twist is a lot to do with this exchange. So when you start to realize that if you could create a parallel field, and that is important, a parallel field, once again, this is how I came up with it in the first place. You create a parallel field, okay, and then you're able to create an energy dense spin, okay, in either direction. I'm going to go over both, okay, in either direction, either consistent with the flow or against the flow of the force that you're parallel to. Okay, one of two things is going to happen. Either your helical index, okay, is going to approach a negative to zero, okay, and as soon as you hit anything over a certain point, I forget what point it is on the chart because I don't have the chart in front of me, but it's like once you get to like 15 or 20% of that zero, okay, you actually start having a gain. Okay, so in other words, instead of the energy exchange rate being pretty much even, okay, all of a sudden you start bringing in more than you're having to give back. And as you increase in that counter rotational direction, okay, you'll hit zero. And at zero, the approximations based on the math, it seems to be that you get approximately a 20% return greater than put in, okay, at zero when it's leveled out. Everything beyond that is actually a linear gain. Once you start spinning in reverse at a high energy density level beyond zero, okay, where it's zeroed out. Now, where it gets interesting is this. You could actually do the opposite, right? Barrel half full, barrel half empty, same thing. Same thing. All right. So if you're actually spinning with, okay, you could actually accelerate your spin by utilizing the torsion of the forces at work when you build your fields parallel. So this should get a kickstart basically running off of that, and then you spin it faster. Okay, now when you do this, something interesting happens, okay, is that once you cross the threshold, okay, which would probably be at the Planck scale, all right, you would experience what we talked about last week, which is shear, helical shear. So it's like anything, right? If you twist and you twist and you twist and you twist, well, eventually it breaks, you know, and the same exact thing happens if you go faster and faster in the same direction. You're already ambiently going as fast as the other field once you saturate it and bring it up into a relationship with it. Now, anything that you put in is excess of that, and you could get a shear. Now, what's interesting about a shear is that rather than push off like the other side is doing, okay, where you're spinning counter. So in that case, when you spin counter, you're pushing fourth dimension away from you. Okay. And just like Einstein said about bending the field, okay, that when it's pulled in close is when you experience the gravitation. When it's pulled in close is when you have time dilation, okay, that occurs. Well, when you push it out and away, okay, now you've broken your locality from your ambient environment, and you still have those effects. But where it gets crazy is when you spin faster and shear, because I propose that when you spin faster and shear, okay, and when I say spin, it doesn't have to be physical spin. It could literally be the spin of a field, you know. Well, once that shears, everything inside of that bubble, okay, no longer becomes dimensionally relevant, because essentially you've sheared away from the third dimension. Okay, so you're still subject to. Now, remind you something. This is where it gets super interesting. If 4D, okay, makes up 3D, I'm sorry, if 3D makes up 4D, okay, and you shear out into 4D, all you are is out of phase. Okay, and I had a hard time getting my head around this until I saw this exact way. When it shears out, you're out of phase with the 3D environment. But the 4D environment, okay, that you're now subject to is still here and made up of this. So you're not necessarily anywhere else exactly, although you could be. And that's the thing. That's the key. You see, because once you shear, you're no longer subject to the laws of the third dimension. Time and space and all in between. But that doesn't mean that you're not here. That you can be here and be out of phase and be subject to the higher order laws by shearing out. So now super interesting. You can shear out in reverse, I would propose.
Okay.
But it would be exceptionally difficult now, wouldn't it? Because you already have to overcome all the forces to hit zero. Then you would have to push it exponentially further to then shear. You see, so if all you wanted to do was see something lift, then you go counter rotational. Okay, if what you wanted to do was shear out, then you go with flow rotational. Okay, because either one will throw you off the scale just in two different ways.
So real quick, 4D to 3D, that conversion, is that light to plasma?
I mean, that could well be a part of it, but light and plasma are not inherently just simply the same thing. They're similar. There's density differences that are probably the most fundamental, but I think that the major difference between just radiant light in general, photon, as they want to say, and plasma as we know it and see it, is that plasma is actually in a state of um energy like matter, or matter like energy at that point, matter like energy, like I had said a bunch of times. So that plasma is highly willing to actually transition from energy to matter. Okay, where because the constituents that it was made from were previously matter.
Okay.
Whereas light in itself, okay, you would need to increase the density exponentially in order to turn it to matter, which is why most of the time, in known and accepted physics, you're going to need, like a pretty high volume of gamma radiation. Okay, usually in order to break down the photon, as they like to say, into pieces that then could become constituent of matter under forces of compression. So there's a whole other subsect of things that have to happen, for light to drop into matter
Mm-hmm.
than it would for plasma to either disperse as energy, okay, or to form matter itself, because that's closer intermediate state is plasma. And it's multidimensional.
Okay.
And it's multidimensional because it's the magnetic component that keeps it consolidated to make it plasma. Even when it's loose and gassy, what doesn't prevent it from going into an immediately diffuse state is magnetic compression.
Okay. I just want to make sure I define going from 3 to 4. You know what I mean, or 4 to 3, however you see it.
Yep.
And then people are bringing up the swinger limit in the chat. So it's just the speed of how fast things go before things get haywire, right? Is kind of where they're going.
I mean, the Springer limit has what to do with it, but when you propose that the energy exchange is local, okay, but then you realize that the ambient environment is created by other local exchanges, okay, you can't sit there and ask the wrong question all the time. You see, you need to work with the forces that you're subject to. So you could break your locality, okay, by using the ambient exchanges of, for instance, Earth and this process. Okay. Whereas, because you are a much smaller piece of that locality. So, it would take much less for you to break it on that scale proportionally. Okay. Than it would when you start calculating overcoming the entire force of the exchange of Earth and this mechanism. Okay, because if you had to deal with that and that was your proportional, remember, scaling down sometimes is scaling up. Something big spinning real fast is seen it's like kind of nothing. Something small going that fast is out of control and never going to happen. It just doesn't have the ability. So
Right.
when it comes to energy density levels and it comes to spin rates or rates in general, it's more having to be in tune with the ambient process to utilize it to your advantage, because you could always use what's around you to at least bring you up to near a net zero, as long as you're going with the flow. If you're trying to break the flow, then this is the relationship that you have to break, but your portion of it is only a small fraction of the whole.
Hmm.
So for you to break it small scale, doesn't take the crazy numbers that they suggest on the Schwinger limit, in my opinion, because by the time you scale it to your applicable percentage of your immediate ambient, you got to realize you only need to push it. You don't need to push it off the whole thing, the sum of the whole. You just have to push it off of a little bit more than the sum of you. And once you do that, then that's it. It's done. It's a done deal.
Mm. Gotcha. Huh. So funny. Yeah, by the way, just so you know, you're not breaking the Schwinger limit with a mechanical device. It's just not possible. You have to do it in gas or plasma in order to approach those type of speeds. So,
Yeah.
yeah.
I mean, high society says, hey, theory is unverifiable until you can prove it in practice. I mean, dead on, man. I mean, that's right. Now the paper that I'm working on the subject, I'm going to throw it out there. Okay.
Go ahead.
It's not ready. Okay, because there's several attributes that I already know I want. Don't have to. Okay, I want to put in there because it's going to strengthen it, and I'm just simply working out exactly how how it has to go in there properly. But I did send it to Nathan. I give him permission to release it as is, and then I'll put out a revision on it when it's all done. Because what I
Nice.
want everybody to do is take a look at it, because you see all the formulas are there, and all the formulas are derived from all the known and accepted science from both the relativity and classicality standpoint, and then bridge the gap to quantum physics. Okay, which I know people tend to hate, but guess why you hate quantum physics? Because they say it lies behind a wall you can't understand, and therefore don't look behind the curtain and don't ask any questions about behind the curtain. Just believe that's how it happens. This is what bridges the gap between that. And it does so in a very non-invasive way, because it conserves energy. It works along with the law of energy conservation.
Mm-hmm.
Okay, it describes all the diffusion events. It describes the diffusion events. By the way, here, mind you this, what I said before. Energy exchange with matter, that's where your time dilation is. Okay. As you go out into diffusion, you know that time dilation doesn't exist in the same way. You know that the four dimensions pushed out. That entropy is the arrow of time, as they say, right?
Mm-hmm.
And that arrow of time is then therefore preserved. Physicists are going to fucking hate me, okay? Because they're going to look at it and go, oh, damn, we know and approve of all these things. All
Yeah.
he's doing is, and then it has all the observables in it. And what I'm working on now is all the data sets, okay, that I've already run that prove the formulas out. So there's one wild card thing that I'm working on, and honestly, I'm open to the chat for any advice on this. Okay,
Okay, go ahead.
but this is on the exchange rate. Okay, now what I propose the exchange rate is actually more fixed than you might imagine. Okay, and I think it has to do with ratios and proportions. Sound familiar? I always backtrack into the same exact thing. So yes, there are variables on either side of it, but what I propose the constant is, okay, is the volumetric difference, okay, of a four-dimensional sphere versus the manifestation of the four-dimensional sphere in 3D space as a 3D object. So there's a clear differentiation that would occur between volumetric space. Okay, and mind you something, that the volumetric space that's missing as it comes over, okay, is exactly the point with all tunneling events. This is how all tunneling events occur. It's, it basically tunnels out into a fourth dimensional object, and then is able to tunnel back in. It doesn't go missing. It doesn't go behind the mysterious curtain. It literally goes into a geometry that is here but not here simultaneously because it's out of phase. So something could evidently be crossing what we would consider to be the same volumetric area, okay?
Mm-hmm.
Except it's not in that volumetric area at all.
Not yet.
Right.
Got it.
So
No, we've seen that with the RAV too, where you had like, oh, hold on a second. Things would show up and looks like it's transferring through, and then all of a sudden you shut off the machine and it goes away, like Sean Snow when he had it. you would see things, pretty on crystal form, and then boom, you turn it off and suck right back in because they hadn't fully formed yet. There's something missing.
Yep, that's exactly it. And it's not that it's missing; it may never come back, or it might very well come back. It depends on what's going on and where it is in exchange, and that's the key. Is because everything also works off of carriers. Okay,
Mm-hmm.
and I was talking to Nathan the other day when we were looking at some toroidal geometries. Okay, and then you were doing dual field toroidal geometries that were inverse. Okay, you're actually able to identify all of the key points in the flow patterns where things change and exactly what the relationship is. It actually proves out the RAV 1,000% as if it hadn't been already. Like I keep on saying, oh, see, and that proves out the RAV. But I mean, there's got to be a point in time where the RAV is proved out. I think it's proved out.
I think one of the things that Rob, and I'll say this, and Joe and I need to do a better job with it. We're seeing things in the background that everybody isn't seeing quite yet, and we're seeing the fundamental relationship between them. And it's our job to get it out in a way that everybody can understand it, and that the people up in higher level physics like to see it in their mathematical form. So it's been a little rocky road for us to go from just talking about things on a casual way to bringing things into physics terms so that everybody's kind of happy with the unified direction of it. And one of the things too is when you see something and you know something and then everybody has a different opinion on it, you kind of have to bring those things together and show both sides of it and where it actually stands in the end. And that's been one of the things. So Joe and I are going to be working on a pilot episode here for the RAV, and that's part of it and how we want to lay it out. Because when we do that, it's going to be the best way to see this thing the right way. And it's going to take several times and several videos to get it right. And we'll throw that in the behind the scenes section of what we're fiddling with. But we can't just put out a picture and put arrows to it. We're going to have to, walk into the screen, show it, you know what I mean? Kind of bring it to life, kind of how the thumbnail did, how you see me standing there pointing at something. It'll be kind of the same way, and we'll do little interview sections on it. But yeah, I just think that's something that we're going to have to do because it's going to come in line with all the papers that are being written on our side for what it is.
Yeah, yeah, that's true. And again, it's easy because what you just said, and then what somebody saying in the chat, Egon saying, that it would take like an incalculable amount of time. Basically, it's a huge endeavor to, describe the universe. Okay, but what becomes very interesting is this, right? When you see and fundamentally understand, this is an opinion, but I think it will get proved out in time. All right, when you see and fully understand this exchange process that occurs, okay, and then you understand how when the exchange process is not going on, how that exact process falls into that. Okay. And it's absolutely seamless, right? And you understand it from the beginning of the creation, the mechanism of the creation, and then all the forces that are at work working both together and against each other, okay, in proportion. And you fully understand this. Like, I mean, I can't say I fully understand it. I mean, I think that would be, not humble of me, right? But, I have a very fundamental understanding of it at this point of study, of what these processes are. And then the thing is that when you start to look around, you realize that everything is either in one state or another, and that it's universally applicable. You could apply it to any single dynamic that exists. Okay, including like there's something personal as like a relationship. It doesn't even have to be physics or energy related because everything is energy related. Okay, so when you start applying it and you see it across the board, you realize that everything actually works along those same principles, and everything is actually just either a wheel or a pulley, and everything's either pulling the pulley, or which is pulling another wheel, which is turning another wheel, and it's all at different rates, right? And depending on the size of the wheel and what it is, right? So it's exactly that dynamic where one thing has directly to do with the other, and then there's that exchange rate, right? A larger wheel is going to turn at a different RPM than a smaller wheel,
Hmm.
right? And once you understand that that's the proportional relationship that exists between all of these things, you can't help but start to reason beyond that veil that they put up and see exactly what it is. We have tension on what we call the ether. I've always had a hard time defining the ether. I said it's our fabric, it's our this, it's the mechanism of that, it's in a state of rest, it's in a state of that. All that being true, but what is the ether? I'm here to give you a new opinion. The ether is the tension that exists, okay, or lack of tension, okay. I should say it's the veil that exists, all right,
Hmm.
between the third and fourth dimension,
Yeah, I'll
okay.
go with that.
So it's your oil on water and that little zone in between. You know, it's weird because you could sit there and drop something in the oil and it never reaches the water, right? You could sit there and poke the oil on top, and well, I mean, the effect that you're having on the oil does not affect that water oil line as much. Okay, there's dampening and stuff that occurs, right? And this is the dimensional difference. This is the offset that I'm talking about. This is the exchange rate I'm talking about.
Hmm.
So it's that's what the ether is. And when we talk about perturbations in the ether, well, what is that? Well, that's the application of pressure on the threshold. The threshold of what? Well, the threshold of the fourth dimension, and that pressure is directly related to um, time and gravity. Space
Yeah.
actually falls on the other end, in my opinion, by the way. Okay, which it's not part of that dimensionality relationship. Okay, but it actually exists from that counter rotational sphere. Okay, whereas the rotational with the flow shear, okay, in one direction, kind of blasts you off that one side, which is time, which also gives you access, okay, key to realize, gives you access to space. But if you're going to blast off of space, okay, you actually have to do so in the reverse manner, okay, because it's the same as reversing the matter at that point. So the same as you're trying to shear off by creating a higher dimensional electromagnetic force by going with the flow, you're actually trying to create a higher mass force when you shear off in counter rotation. So it's the opposite side of the spectrum.
Okay. I, you know, real quick, a couple things. The standard model of physics on the atom, once you see the rad build out and you understand what the satellites are, it'll give you a whole different perspective on the atom itself and what they're actually doing, which is in line but just slightly different from what they have as a standard model. Um, and then, real quick, the energy and photons and stuff, you can actually see exactly how you measure the speed of light and what it is based on the RAV. So you'll understand the energy and how fast the main star has to pulse before any planet pulses. You know what I mean? In between, and you can measure that rate and see, the light speed in it. And it's not actually, it's kind of like a mislabeling of what it really is. It's not actually the speed of light, it's the speed of energy that produces light on the other side. So it's more like the photon effect. How long does it take before the photon goes off in any single object? and then that's the rate of time. That's the speed of light. And
Now,
then
interestingly, I mean, and like you said, rate of time, speed of light, where a lot of this is broken, okay, is the fact that we feel the need of measurement in general. Okay. There's a couple of reasons for this. All right. The first reason is that time is not a constant. Okay. So since the passage of time is not constant, using it as an objective measure becomes pretty haphazard at best, if you want to put it that way. Okay. Secondly, um, per their own admission, and you know what, I'll agree for reasons I'm not going to go into. The wave function isn't exactly what they make it sound to be. Okay, because there's different levels of wave function that
yes,
actually occur. Okay, there's a collapse of a wave to a particle if you want to think about it that way. And then they'll contradict themselves and say, well, that's not literal, but it kind of literally is. And that's ridiculous. The idea
can't
is
say
that,
that.
right, the idea here is this they've set up their own traps. All right. They've set up traps where, first of all, they're running tests in an environment. Hate to tell you something, you've already collapsed a wave function that's occurred by virtue of it being in the presence of an environment in the first place, because it's automatically in a collision course with matter. Okay. So, right in itself, if it's acting as a wave, it already partially collapsed by virtue of you perceiving it that way. All right. Secondly, if you measure it, well, that causes the collapse. But if you don't measure it, okay, then it's not empirical. So it ceases to exist because measuring it collapses it, but you can't not, you see what I mean? There's like a but for here that is occurring that becomes very contradictory. And the idea here is you can't calculate the speed of something when time is part of the measurement, because time is a variable, not a constant. And then you can't sit there and say that something is something definitely when you're actually measuring it while transient. Okay, because if you're measuring it while transient, then you've collapsed it, and then you can't make a clear judgment of what it was actually doing before you changed its phase. Hi, but then if you actually bring that into account, it's not empirical. So when you see crazy shit happen at a distance, okay, it happened faster than the speed of light, so there must be some other kind of connection. Yeah, no shit.
Well,
The connection is that it's not light speed unless if you observe it, and the connection is that it wasn't in this dimension; it was in a state of rest. But in that state of rest, fell off of our three-dimensional plane and into the side beyond the veil, where it's actually traversing a much different environment, where it could actually travel that fast, however fast. So
okay,
it's ridiculous.
let me say this. We say the time's emergent. So it's emergent one speed in this solar system, but it's an emergent at a different speed in other solar systems. You could tell by the size of the sun. The speed's going to be different in that area. Okay. It goes throughout the solar system that way, and you got to think of it like this: once you get outside the solar system, is speed the same? See, how fast does energy travel through that? We're in a bubble. That's the problem. We're in a bubble. We go outside the bubble, yet we're still in the main bubble of the entire cosmos, right? So we're never outside of that. So we would never understand what's outside of everything if there is no time whatsoever out there. Everything that we know is emergent from the bubble that we're in, going into something that would be a different bubble, which would be the cosmos bubble, then going into another solar system, which would be its own bubble, which means everything has its own time. That's why time's emergent from everything else, because every bit of it's different. So one solar system could be twice the speed that it is in our solar system, yet we're measuring the speed of light based on our solar system, not theirs. And then we're trying to get an idea of what they're doing. How fast that thing blew up or when it did, we have no idea. Okay, until you get in there and measure that solar system and understand it that way, you can't put the two together. Okay, that it's just incomprehensible that you would think that it runs at the same speed that we do. It can't. There's no physical way that it can. It emerged at a different speed than what we're emerging at. Okay, and that's kind of the point. When you see some of the stuff that goes on to the lab, you see light emerge into matter, emerges into plasma. Well, how long does it take? You know what I mean? What's the universal constant in the solar system? I don't know, because the sun runs at a different speed than the Earth does. The Earth runs at a different speed than Jupiter does. You know what I mean? Because they're creating their own little environmental condition right there in their own locality. So even in the same solar system, you have a problem with it. Now, the speed in between each planet would change a little bit as well, because if you know anything about magnetism, as soon as you have any kind of field that goes on, it has a drop off rate. It has a time variant to that drop off rate. So the hardest thing to understand in this whole thing is time isn't what you think it is, but then it's not what they keep saying it is either. So you have to really go way beyond it to figure it out. That's why it's hard to put it in as a measure of unit. It's easy to put it in an equation saying, okay, it's my electrical system and this is time. If we go into a solar scale, it makes it much more difficult. You know what I mean? We have to
Yeah,
know a lot more
there's
factors.
like, I mean, and it's the relative relationship. And I think the weird example is like if you have an old school vinyl player, like a record, right? Yeah. Oh, how long is this, shit Beatles album that, found in the garbage because it was overrated in the first place? Oh yeah, well, it's 40 minutes long, you know. Okay. So that's what? Oh yeah, it's 20 minutes per side. Okay, cool. So what's the duration of one side? Well, it's 20 minutes. Wonderful. Well, it spins at 45, RPM or whatever it does, or whatever the rate is. Cool. So you play it at 45 RPM and it takes 20 minutes. Or, you spin it at 90 RPM and well, then it takes 10. Oh, what just happened there? So how long was it? Oh, it was 20 minutes. No, it took 10. And that's the whole point. It's all relative to what? To your ambient, the speed. If you're trying to lock something in, it better be a constant. But when you're trying to lock in something that's a variable, then you sit there and of course everything is retarded, literally, in the literal sense of the word. You know, yeah, everything's in a state of retardation because you are in a time dilation zone where everything to you appears to have super low go like this. And that's just what it appears because of the compression that you're under, the compression from the fields that are created from what? From an energy exchange with your environment and with this pressure that's put on our dimensionality.
Okay, so
I think he's
let's
trying to squeeze us out of existence, you see?
let's go a little step further into that. When people get in the zone when they're working out or they're playing football or something like that, right? They're running the ball. It feels to them like everybody else is slowed down while they're moving very fast,
Oh,
right?
yeah.
But that's the emergence of time.
That is, and we've talked about mechanisms, potential mechanisms of, neurological functions that we know well exist, okay, that could have direct correlation to creating neural pathway, aka circuitry, therefore fields, okay, in your literal existence that time is not, feeling, like it's going slow. It legitimately is objectively hyper locally slowed down, hyper locally. And that's the whole point, because and that's the beauty of this paper that I put out, is that all of it has to do with hyper locality. Okay. Um, and that locality is present both macro and microscopically. So it's subject to all scales and it's scalable and it's proportional. right? So it becomes all relative. These all sound like words that generally you hear when you hear the gloss over physics because they're very safe, okay? But the thing about it is that just because they're safe, just because they're predictable, doesn't make them wrong,
Right.
right? It doesn't make them wrong. And I think that that's where most people who try to tackle this subject fuck up big, is they look at it and they're like, it's crazy that they're locking themselves into this. It's so much more. And then they get hyper focused on all the wrong points of it. And they try to change everything, when the answer is that actually they kind of got it right. There's been some smart people out there over the years. Can you believe it? You know?
Well, okay, it's like gravity. The hardest thing I found people think it's a fundamental force. It's not. It's the accumulation of forces together of fundamental forces that make it. And once you realize that, you can't put it in as a constant. That's again the constant problem right there. And it goes to time is emergent. If time is emergent, gravity is emergent from time. And you would also have to take that into mass. Now, when you calculate mass, you can't just calculate it as solid rock. You have to calculate it as gas or plasma as well, because that'll accumulate mass as well. So Jupiter's mostly gas and plasma, has more mass than the Earth. The mass on the Earth is rock and stone and things like that. You know what I mean? But we still have gases that come out as mass and things like that. There's a way to see it a little differently. The gravitational field on Jupiter is much stronger than the gravitational force on Earth because Earth is mostly rock, and where plasma and gas are the emergent force in Jupiter, it changes the gravitational field. So if I want a gravitational field that's stronger inside of Earth's atmosphere, I need to do it in gas or plasma versus anything else because I know it's a much stronger field in gravitation. That's kind of the point of the RAV in what you see emerging everywhere. In that fundamental state, it's its highest energy level you can get. As you add more matter to it in the way of rock or anything else, it lowers the amount of energy in the whole system. That's kind of the way it works because it's being used up to help hold it together
Mhm.
instead of giving us our effect of a gravitational force in
That's
itself.
it. And that's what I've called the lock. And it
Yeah.
goes into these energy locks that occur. Okay. And it could be a matter can induce energy into a locked state. Well, how? Through magnetism. You see?
Yes.
And matter could also chemically, um, as we would call it, chemically lock energy by utilizing it as the glue to hold it together through, it's electrons. Um, and it goes into all this paper, right?
Hmm.
And relevant to exactly that. And in the paper, and I kind of want to read actually this one snippet because what I realized is that even though it had the energy locking, okay, in there already, it didn't account for what we know about the rap. Okay. And here's what's interesting. When I hashed out the language, okay, when I kind of went back and forth with, frankly, I mean, I was like using AI as a tool,
Hmm.
to sit there and hash out the language. And I was kind of arguing with it a little bit, but telling it not to agree with me unless if it's, you know, on point,
Hmm.
separately verifying. This is why it took me so damn long. And then it gave me the equation, okay, that I was looking for. And then I was able to then separately verify that equation not only works with the functionality of the rest of the paper, but works just generally. And it directly has to do with the RAV. So can I read this?
Yeah, go for it.
So it's section 3.4, and it says minimality and physical motivation of the exchange function. Okay. So it says we motivate the exchange rate density as a measure of sustained local non-equilibrium maintained by asymmetric differentials in an intradimensional exchange. In this picture, patterned electromagnetic configurations act as locking boundary conditions that inhibit full relaxation to a diffuse potential state, producing a locally stable but non-equilibrium energetic manifold. Any, any admissible must therefore, one, be local and covariant, two, vanish in the absence of relevant non-equilibrium structure. Okay, does that sound familiar?
Hmm.
Three, reduce to standard um, conservation in the null coupling limit, and encode electromagnetic offset parallel structure in a frame invariant manner. These constraints severely restrict functional freedom, in particular, the electromagnetic pseudoscalar invariant. Then it goes on to give the equation that says that it provides a unique Lorentz invariant measure of helical phase locked field geometry corresponding to uh, parallelism or partial parallelism between and since changes under reversal of the field um, handedness. Okay, so there's a reversal of the rotational helical. Any exchange coupling proportional to the yields a sharp experimental discriminator via uh, helicity sign flip test. And then it says, finally, because the proposed exchange is hypothesized to manifest as an observable energetic effect only when energy is anchored to classical locality by interaction with matter, we include an explicit matter coupling factor, such as the local mass energy density. Okay, this suppress unphysical exchange everywhere behavior in the vacuum limit. And wait, this suppresses the unphysical exchange everywhere behavior in the vacuum limit and reflects the postulate the decoupled energy relaxes toward diffuse and potential states, and then gives three more equations to prove it out, including covariant measure of pattern non-equilibrium locking.
Hmm.
So that's the wrap, and it's in there, and it all works out. It all works out just fine.
Yeah, that's kind of crazy, man. How perfectly that whole thing did it. I couldn't believe it when we're building that thing out. I mean, we all have kind of like a thing when it comes to the solar system. We all believe something, and my belief has always been that there's been how do I say it, like a ring around the sun at different levels, and it goes out to each planet, and then each planet pulls the energy from the sun on that ring and then exchanges it back to the sun. You know what I mean? Right through the top of the planet back down to the bottom, and it goes back around to the sun. And it does it for every single planet, but each one of them, as you push out further, the frequency going to each one, or the resonance frequency, changes in each one of them. But to see the RAV do it, and you see the light build out, and as soon as it hits the point where it's able to spin right there, once it hits that spin zone, it built out, and then it started swirling it. And as soon as it did, it built its own satellite right away. So you get this RAV over here, you get this smaller satellite RAV, but that has its own satellite right here. And you kind of just get to the understanding of, is this the way planets build out in a solar system? I mean, it's energy to matter, and we're seeing it right in front of us. It's a little bit bigger than you would see in atom state, but way smaller than you see in the state of our solar system. But it's generally doing the exact same thing. It isn't a collision, it isn't the accumulation of rock. It's built that way in the solar system from the very beginning. That's what's crazy about it. Then
Yeah.
what you see is you get pulses that happen in it. So where's that line that goes on to the planet? It moves. That's the crazy thing. It's moving and it's pushing that new structure out a little bit. So you're realizing that they all could have been created in early and pushed out. So it gives credence to a lot of science that people in the solar system community deal with, but it also gives them a great structure to look at and say, hey, if this is true, and I say if this is true, then this is a perfect concept of what happens when we build out a solar system. Okay. And then they can identify it and use it in their research. That's what I love about it.
So there's something else interesting that kind of came to mind with this, and this is another part that I'm still working on. Won't be a part of this paper, but definitely something significant. Okay, and that has to do with iron. Okay, and the fact that it's magnetic in general, and that it's able to also hold a magnetic field for any extended period of time. That's a very unique property by and large, right? And the implications here, okay, is that the lattice structure of iron itself, okay, lends itself to being charged to higher energy states, okay, and being able to actually entrap that energy. Now, once induced into a higher energy state than ambient, and that threshold is pierced, okay, it itself becomes magnetic, and then ultimately has a magnetic field. And anything that's able to hold a magnetic field without a consistent charge, okay, can only really do so if four-dimensional coupling has therefore occurred. So that's how hyperlocal this is. You see, you induce an initial charge. Once the threshold is pierced and it was able to hold that charge, the charge was able to structure because of the lattice. Once the four-dimensional field itself was formed, it's then coupled to the four-dimensional field with an energy exchange rate. And as an iron magnet that's induced into magnetism will not stay magnetic permanently and forever. Okay, so there is a diffuse element to it, which makes total sense. And it also makes sense that as that diffusion occurs, that the threshold will be closed, and that will cause it to lose its magnetism altogether. But as you're well aware, the only thing you need to do to bring it back is actually bring another magnet to it once it's previously been magnetized.
Mm-hmm.
Okay, and once you bring a strong enough magnet to it, it actually brings that into its own field and allows for recoupling to occur without a current. And you see that that's how that goes. Like it just has to do with like certain things' ability to hold, store, and organize. And then once it's actually reached that high energy state once, then it can actually be brought back again as if it has a memory. And that is direct proof of the coupling.
Mm-hmm. Oh, I want to show something. It's because of a comment right here. I just want to show time energy, time energy fractal. So, and this is something that Victor is on all the time with the fractals. So let me go ahead and show this to you. And it has to do with what we saw in Sean's experiment on the snow. Okay. If you guys remember, he would have snow build out on it, or we call it snow, but it's basically a fractal pattern. And he looked into it more. I just want you to pay attention to the upper right. So right above where it says play right there in the center, I'm just going to hit play and just look at it. You'll see it grow. I thought it was the coolest thing. So you can already see it coming out of there.
See all sorts of stuff in that picture, Nathan.
Oh, I know. We're going to have to slow it down and evaluate it. I just thought everybody liked to see this because you could see it continuously growing and growing right off of it.
That is, by the way, like we've been saying, That's a direct result of the energy exchange and what it's doing, because it's pulling the bits and pieces apart and separating them and allowing it to accumulate dendritically on that side.
Hmm.
It's just low energy density atomic mass. Realistically, it's
Yeah.
an accumulation of particles.
Yeah, you can see it growing on there. That's crazy, isn't it? There wasn't anything there before. Now we're what, like a quarter inch out almost? Yeah, we'll have to zoom that in. Let's see. He starts that one. But I wanted to show, let's see if I have it. This is what he's getting, okay, when he does it into glass. And you'll see the fractal pattern in it. And this is really cool because he figured out exactly what was going on with it. And he showed this here. And it shows a similar fractal pattern. And
It's definitely fractal like that.
yeah, um,
So that's interesting because when those dendrites, when they build out in volume, okay, as opposed to just like they kind of form mostly flat dendrites because they only form in low energy states like that, and they form fractally. But what's interesting is that when you add layer upon layer, okay, which could really only happen with pulse phase shifting, right? Um, they grow in volume, and that volume actually grows out to be what they consider to be a botryoidal um, growth, which is compressed and coiled up dendrites, right? That end up just forming into a bubble. And those bubbles, if you cut them open, you could see that they fractally are very, very tiny at the top and almost form like a skin, as they reach a termination point. But the interesting thing is that they reach the termination point, right? And
yeah,
then when they do, they start to grow up, and they're always going to have a lattice um, restriction as far as how much volume they could obtain. That's proportional to the lattice. The reason for that is exactly the same as why spheres form. Okay, which is when it goes into that state, and this is just reverse of that. When it goes into the state of diffusion enough, it starts to collapse back onto itself. Well,
hmm,
that when that switching process occurs and the reversal occurs, um, that's the formation of your equatorial plane of a sphere. And we've discussed that many times, and that's all present in how the field's built out.
hmm. Well, I wanted to show this real quick, Joe. It's called the Julia set.
Mm-hmm.
Is what Sean discovered it is, and you can see in there they got fractal patterns and how things build out, and they have different formulas in there for it. Just so you know, everything's on Wikipedia if you wanted to look it up. The cool thing I thought is I remember looking at this with Victor a long time ago, and we were looking at the fractal patterns and everything else. But this is clear direction of I don't know if you called it an emergent state, transmutation, whatever you want to define it as. We're getting it on the other side of the route. You know what I mean? We're seeing how it builds out from the beginning, from light to plasma, but then now we're seeing it once it's in the plasma state and it's had a chance to work on a certain surface. You're seeing it come out in a fractal state. So I think we're getting a pretty good timeline of beginning, and I don't think it's the end, but I think it's the start of the next level. But I wanted to point this out because
Yeah,
it's
yeah. This whole thing that you're looking at and what we're discussing right now is literally just a zoomed out version of everything that we discussed at the first part of the episode with the the paper
mhm.
situation. Okay. And in fact, I will go out on the strong limb and say that not only was it the direct inspiration and realization of being able to put that sort of thing together, okay, but the smoking gun that was both for the flare, okay, being the high energy state, and then realizing that it has a quantum feed back to the RAV itself, okay, was the total realization of what the mechanism of it all was. Because when you look at the magnetic fields and how the eddy currents are causing states of compression, but also perpetuating the magnetism. So it's working against the magnetism, which is making the magnetism push out, which is pushing on the magnet. It's like it's that torsion, okay, that occurs. The mechanism for vortices, right? So the vortices form and they become wells, and one becomes a matter well, and the other one becomes an energy well. And the energy well, okay, it doesn't look like much, okay, but what you see is that you actually have the entire sum of all the energy matter interaction, okay, that's leaning on that eddy current, okay? So it's stronger than hell, okay, is the point. And because it has everything leaning on it, it's like every pulley in that system leads to that final gear. That's the one that's turning the strongest, the hardest, the fastest, and that's what gives you the access. The access to what? The access to the energy well, of course, the one that feeds the RAV further. So it uses this interesting where it's picking up the diffuse forces, except they're not diffuse. They're just diffuse compared to where they're strong. But it's picking up all of them, using that to sit there and then counter feed an excess of energy directly back to the RAV itself. And that's not my model. That's the NASA and physics model based on the magnetosphere, based on the sheer, the Holtz, whatever things that I was talking about last week. I'm terrible with names, man.
I want to show everybody this too.
Yeah,
Now,
Kelvin Heltzel.
so one thing that we do, guys, is we look back at ancient history and what they wrote and see if anything matches what we're looking at. And I just kind of want to point this out. You see Jesus right there, you see his head. Remember when we showed you the RAV and we showed you the black light and it created the cross? Well, you see that right behind his head, right? Two of the things that are emergent colors all the time is the blue and the red. We also see where he has that, forgive me for not knowing the name of the metal device right there. It shoots right into the center, okay? And it makes like a little blob. Well, that's exactly how the RAV goes out and makes another structure in light, how it goes straight to it, builds it from the center, and then it builds out, and then you see little satellites around it. What you're also seeing there is when the black converges to blue, you're getting a fractal pattern. And that we're seeing that as well. Now, I don't know if this is something that somebody drew over time, or if it's a religious thing that's been around for a long time. Let me just tell you, one of the secrets they were holding back forever, and this must have come from a civilization much more advanced than us, is high voltage and high energy states create all of this. And we're seeing it everywhere throughout the entire planet if you understand how to read these things correctly.
Yeah, that's a compass, right? And just as significant as the symbolism of what Jesus is drawing there. You have the compass, but also has the measure on the compass. Okay, you could see that it's set to 45 degrees. Okay, and what you see is the measure, okay, perfectly curves over the North Pole, and that it's directly set on the North Pole. Because that is significant, like as far as, again, all the angular aspects are concerned. And then there's how relative it is, because even though its compass is set at 45 degrees, you could see that where it falls at the equatorial plane because it's a sphere that he's measuring and not a circle. Okay? It does not fall at 45 degrees. All right. And that's probably significant. That probably looks more like probably like 42, 43 degrees.
Okay, real quick, got another one for you. And let's see, this one
But
here.
when you show the next one, let's do the chalice.
Oh,
after
yeah,
that.
yeah. I'll bring that one up next. This was the fractal snow on the one that Sean created, the one that you saw the lighting come up. You can see it really easily now. It's all created perfect little structures in fractal form. And we always call it snowflakes. I'm sure there's a better definition for it in physics, but that's what I like to call it, just snowflakes. It's spitting out the fractal snowflakes.
It is a good point to put it that way because if you look, even though they look like they have a little bit of volume to them, they're not. They're built on a plane.
Mm-hmm.
It looks like so. It's actually weird because we're just missing the volumetric, portion of it to get this to actually crystallize into, a solid lattice pattern. Is what it boils down to. But we're missing a dimension. Like a snowflake builds out, it might have a piece or two coming off another axis, but everything runs on the plane, and there's nothing ever connecting the plane. You see what I mean?
Mm-hmm.
So that's the same thing here. Yeah, it's really cool.
You wanted to see the chalice, Joe?
Yeah, show them the chalice. The one that I drew on top of, if you have it.
We want to see the one without it first?
Oh, sure.
This one right
So,
here?
yeah, so that's the symbolic Holy Grail of Vienna. And what I did was I looked at it and I was like, wow, we've seen it before, but let's see it some more. And this is what you end up getting when you trace it out. And if you look at the top, I didn't even do the top, but you see how there's a ball and a ball and a ball and a ball, and then it's got a ring on top. I didn't even do that part, and that's even more significant because that's the flare. Okay. But if you just are looking at the chalice alone, all right, these are the magnetic fields and the mechanism of the creation of the raft, just as I put them. You can see where the lines actually start to cross, okay? Because they're parallel, they push away and bow out like a heart. They bow out. But then once they complete their return and they're coming back with whatever they took with them, okay, that's when they cross. When they cross is when they ultimately it reaches a controlled equilibrium state if it's in an intermedium. There's no circuit connection, it's just a controlled intermedium state. So, but you can see it right there. You got the ring in the middle with a small center line running right through it. You got the bowed fields that they cross there, and at the top they form the outflare of the magnetic field. And then you see the bowing of the magnetic field in the front of it in the diffuse state. And then you actually have a whole bunch of little randomly placed pearls all over there, showing that it's, in a state of diffusion. It's in a state of points there. It's not a solid, but you can see that it's all structuring up. But if you go back to the last picture, right, you can actually see, and I know you can't zoom in. I know you have a hard time with that. But if you see above the chalice now, you see there's that big ring, like that clear disc plate.
Mm-hmm.
Okay. And then above it, you have, below it, you have a ball, then you have a ball, and then you have smaller balls ascending up. It's exactly what occurs in the energy well. Okay. And what you quickly realize is that you have your matter well on the one side, it's the one vortice, And then on the other side, you have your high energy well, and that's what that is. And that's what it always looks like. It's what it's looked like forever. It's what it looked like before they had cameras or lenses or reflections to to sit there and blame it on. It's always what it's looked like.
Yeah. Real quick. Okay. So we saw that one, right? So let me pull this up. I want to show this one. Okay, so if you guys watched Danny Jones' podcast, man, you guys have all seen this picture before, and you see it throughout the entire world. And what they didn't understand is something that we came across in anti-gravity and trying to figure something out between Joe and I. What's going on with energy conversion when you use an inverter? And you have to look at it in that way. You see the square wave, okay, and the square wave makes the sine wave, but it's not a perfect sine wave. And this is important because the earth goes through this. When you look at everything in the earth, it builds out like it's a DC system, but then it starts to spark over when you get lightning, and it's an AC system, and it's going between the two. And you have to kind of see it as like a DC is a hover state, and the AC is a moving state that will actually create the propulsion in it. And that's where we come to in this. And it's all over the world for a reason. It's because it's the two states of energy that are going on inside the earth at all times. And just so we all understand how to read this, the square wave itself is just based on the frequency that it comes to, and then it goes across, and then it goes down. And they knew this a long time ago. So the next level up, the only way to create that on your oscilloscope is to bring up the frequency, which would be the pulse level or the height of it, and then have it go across for a duration. And then the one in the center, which is blue, you'd have to do the same. This is the problem with the whole idea that DC has no frequency. No, it's they have a frequency, it's a set level. And they knew this a long time ago.
Mm-hmm.
Okay. So this is why when you put a sine wave over top of DC signal, it starts to appear all the time that have all the properties of the sine wave. Okay, including the frequency, even though it's a pulse rate. So I just
Yeah.
wanted to give you that.
So check this out before you get rid of this picture. Okay. So if you look at the top where it's all structured up like that, and you look
Mhm.
at the steps of that, I don't know, pyramid, call it, what the DC representation is.
Uh-huh.
Okay. You have exactly the path that's followed with the charts that we reviewed last week and what we should revisit again in context, right? Because we've expanded on that. But what you see is it's a doubling. Okay. So you have a doubling from the first step to the second step, and then from the second step to the third step. But then it's halving, half, right? And if you look at it proportionally, okay, as to what amounts of the top to the second row to the bottom, okay, you quickly realize that it's actually working in thirds. Okay, so it's working at like a 2/3 step, right? And when you fully understand that one waveform, okay, of the one pyramid does not demonstrate, okay, a full cycle. All right, that only when there's only one waveform like that without a return, okay, what you end up with is just a nodular cycle. All right, you need it to return to define the antinode. And on the return, so you have to complete two. That means that the equal of in order to measure the waveform ever, okay, realistically, you need at least one full cycle of node, antinode, node, and get back down. So that means that the sum of the whole is two. Does this sound familiar? Sum of the whole is two, and then working with 2/3 and 2/3 and 2/3 and 2/3. Then when you calculate how many steps of 2/3, you end up with certain ratios, and certain ratios are offset. You know, and what are they offset to? Well, 2/3 and 3 seconds is what it comes down to, because when you count the number of steps altogether, it goes from 3 steps up, 3 steps down, 3 steps up, 3 steps down, plus 1. Okay. And the plus 1 takes it from a 9 count to a 10 count. And that's how you get your asymmetry. It's a very interesting thing. When you plot these out, you start to see, like Nathan and I were discussing last week, this relationship that exists between the AC carrier of the DC pulse. Okay. And what you end up realizing is that there's an inherent relationship that exists between the two, with the AC working as a carrier to the DC. And that there's an offset when the DC pulses. You know, that if you were to put it in terms of a frequency, even though pulse isn't a frequency, okay, the wavelength, so to speak, right, of a DC is going to be longer than that of a AC, even though the frequency would be the same, because the cycle is the same. You see, the cycle is the same. For every one process of going up and down, it pulses twice. Up is 1, down is 1, pulse, pulse. All right. So that is the same frequency, but the wavelength is totally different.
Yeah.
And that's because it uses the AC as a rider.
So I want to say real quick to Darren, thank you very much, Darren. 50 Man Build memberships, dude. You're totally awesome. Hooking us up
Man,
again, brother.
you really are the best. You always come through huge, man. Everybody's going to be a member soon.
Well, we hope so, man. Hey, I want to point this out as well. So, by the way, Darren, hopefully everything went well with the surgery. I know he just said he got out of it. So,
Oh, I'm sorry.
wishes
You know
to
that.
you.
Best wishes, bro. Feel better.
What the circle is, just so you guys know, underneath that, the square waves right there, it's kind of funny how that comes out. So,
You either see it or you don't, Nathan.
yeah, it's the 369 pattern that you're always looking at, but it's that pattern plus 180 degrees out, plus turning it to the right and turning it to the left. All of it overlapping each other, and you get a grid. So in all 4 dimensions put together, it forms a grid pattern. And that grid pattern, well, happens to be the same grid pattern that we see all over the earth, known as the ley lines.
All right, I'm going to kill you, dude. Yes, that is what that is, but you don't have to do that, because that's not exactly what happens. Okay? It's the 369 or the alpha, the omega, or whatever, however you want to think about it.
Mm-hmm.
Inverse, okay, with a keyed Ankh or Rochi. Okay, that's it. In fact, the Rochi is a better example of that. When you key that in, that is precisely and exactly what you get, and that was the prediction all along. All the geometries reside, and vectoring patterns reside within that geometry.
I just think it's funny how it works out, and the symbols are everywhere. By the way, when they show them in doorways and stuff, on the symbol up above, do you see the 3 levels? They go inside each other like key lock. Just remember how things work when you think about it. The magnetic field is always what, 90 degrees from the eddy current field, but you get what I'm saying? They knew it was there. When they look at this and you go, okay, I got this waveform here, that's magnetism. One of them's eddy current, right? I understand which one's going where. I also understand. Let me take this down and say this because it's important, because people ask for updates on the gravity flash. So let me just make this very clear what we're talking about here. When you use an inverter, you're putting in an oscillation. Once you put in an oscillation, you're getting a DC pulse while you're also getting a sine wave. So you're getting a manufactured AC. It's the exact state you want to be in when you are sitting there and trying to make something lift, because it's going in between the two. The AC state lifts, the DC state hovers. Okay, we see it in the gravity flyer, and we're playing with magnetic fields and eddy current, right? And we know that they want to be 90 degrees from each other at all times. So what are we looking at? They're on two level planes to each other. They're finding a state where they want to do this to try to correct it. So it'll turn at a 45-degree angle just to try to correct it. The object here is, how do you get it to change the direction? How do I get it to go like this, right? And the answer was quite simple. All you had to do is stall the motors. As soon as you stall the motors, the eddy current takes over and makes it go backwards. So as you're normally rotating one direction, okay, which is the same direction as the upper motor, you then stall it. What happens? It goes back the other way. That's the eddy currents taking over, but it's also taking over inside the field. So when it does that, you're looking at the geometry of it, and then all of a sudden it goes like this. Because it's trying to get over there. It's trying to correct the geometry. It's always trying to correct it when you're doing things, because it likes an equilibrium state. So that's what the whole function of this thing was when we're looking at it and we look at lift. The harder thing to understand on this thing, and I was trying to tell Joe, is the guy's using like 3 or 4 different things in order to create the state that normally you plug into the wall and get an AC state, right? But you can't just do it that way, because you're not at a high enough energy state to be there. Everything is high in all of the energy states, but it's not a permanent state that they're in. So they're in a very low permanent state, right? But then they amplify to this very high state. And it's non-dangerous to be around it, where the state that you would think of, the plug in the wall, is very dangerous compared to this. The high voltage state strips out the other side of it. It's stripping out magnetism. It's stripping out, the energy in it to get to the magnetism part. So it's breaking down fundamental elements right in front of your face, then combining them in one specific way, and then taking them back apart. So you're never getting this state where you're frying inside the thing, that you're getting cooked in an oven. It's
Right.
because it's
And that has to do with amps in the first place. Because if you just think about a wave, like the physical depiction of a wave, okay, and then you are trying to imagine this wave uh, to break apart a molecule. Think about how small. Okay.
Mhm.
Now you could have the lots of frequency is going to be helpful, because you need to be able to knock down your amplitude significantly. Because here's the thing: if the amplitude's too high, it will knock the pieces around, and it will break the pieces off, and it will heat the pieces up and cause them phase change, cause them
Mhm.
to shift, because it is larger than it, and it will push it. Now, if you have a very low amplitude but very high frequency, it's able to actually, like a knife's edge, go in there and split it through its oscillatory uh, force. It's able to physically and mechanically, as anything else, actually break it, rather than push just a whole bunch of them or affect a whole bunch of them, causing resistance and heat and phase change, because resistance, heat, and phase change is contrary and different, okay, than breaking apart a molecular structure or stripping something from a molecular structure and leaving the rest a shell of itself, right? A shell. And that's the point. It needs to be able to go in there, grab the energy that it wants, and move out. And as it does this time and time again, it's literally pieces just disappearing off of it, disappearing off of it. Disappearing to what? Well, disappearing to this this potential state, where then it's just going to accumulate that leftover shell of a mess, on one side and take the energy, the glue with it on the other. That's sort of the deal. And if you have high amps, you're going to get one thing before the other every single time. And it just goes to show how, it's that logic that you have to follow. That goes to show like how low energy a nuclear style reaction can actually be.
Well,
It's
that's
it's not low energy, it's low amplitude of energy, which is like from the usable common perspective, which is why I'm wording it that way, right? It's not a lot of strength. It's not a lot of energy. It's you know, yeah. You get the gist.
yeah. So I wanted to bring this up, and it goes to the state of metal around the energy. We notice this a lot when you play with your Tesla coil. Everything around it, if you have the correct energy state, becomes hot to your touch, but it's cold. So you'll measure it as the coldest thing, but there's a lot of heat into it. That's the entropy at work. And I'll explain it like this: that's a nuclear signature inside of your aluminum. It comes out as when you put the little gun on it, it comes out colder and colder and colder every time you get to it. Okay. And what it's doing is it's trying to work to a superconductive conductive state. The actual thing in radiation is blazing hot. Okay. So it's a contradiction in itself, but that's what entropy is. It's pulling in from the radiation factor. You're interacting with radiation when you're dealing with these fields because whether you know it or not, you're compressing everything into that plate. So you're
Yeah.
not allowing it to go further out. That's the problem.
So the radiation aspect of the heat is actually very interesting because the nature of the radiation, okay, is that it's not part of a current vector, okay? And because it's not part of a current vector, okay, it's going to disperse its energy on interaction. And part of that dispersal is going to be massive amounts of heat. So again, the entire reason that everything we're talking about works is because it's in a state of exchange, and it's not in a pure circuit, right? It's just it's in a continuously evolving current state, okay, through different vectoring mechanisms that it naturally falls into. And as the vectoring changes, so does the electromagnetic mode that is prominent in that particular zone. And the one vectoring and mode that you get in any particular zone works as part of the overall system to perpetuate this exchange until both exchanges are complete. And once both exchanges are complete, then the system is looped. Now, that doesn't mean that you don't need energy to run it, right? But it's looped in the sense that it's creating its own grounded circuit. It's like that's
Right.
what
Oh,
it's
it
doing.
is.
It's creating its own separate grounded circuit. Um, and radiation doesn't have that. Radiation is being thrown out with no opportunity of return. That doesn't mean it can't have an opportunity of return. It just means that generally speaking, it doesn't, which is what makes it radiant in the first place.
Yeah. So check this out. The colder that center plate gets, the hotter it gets on any metal surface in the room. Okay.
Oh
It's
yeah.
just, yeah, there's an exchange right there. And that's what's going to get you to superconductivity. And I know this because when we put that same energy inside my Rodin coil, it started to run for almost a minute afterwards, right after you pulled the wire out and you're looking at the wire and you're looking at this thing and it's still running and you're wondering why, because it hasn't gone back to an equilibrium state. Understand this. When you're dealing with that field, it's in a non-equilibrium state and it wants to get back to it. But as you're pushing energy, it goes further and further away from the state. So you're forcing the bubble inside of the actual atmosphere that you're dealing with. And the direct correlation is radiation structures air. So you just got to understand it for what it is. When you turn on your Tesla coil, you're using the radiation of the Tesla coil to structure the air around it, giving you a field in which light bulbs will light up in. That's exactly what it's doing. So you got to think of it like that. So what's going on with the actual gravity flyer? It's doing that. They call that the nuclear moment, the blue and red shift, however you want to say it. It's actually building it in the air itself, just like the RAV does. Okay. And it creates the field around it. Now,
Yeah.
because it structures the air, it allows certain things in and it won't allow certain things out. That I've been saying that forever, and it works exactly like that. So your energy states must match that. So another cool point about this is is how this electrical system works. So I got to go over this because this is something that people generally probably would never understand. If I took a PWM signal and I put it in a DC flyback, I can attenuate the frequency, right? But if I don't do it on that end and I wanted to change it on the other side of it, okay, I wanted to use a frequency that it was touching in order to put it back onto the actual DC flyback, right? So how do I do that? If I use the ZVS to power the DC flyback, it becomes very hard because it's a zero voltage switching system, okay, back and forth. But if I use one transistor in order to build that state, it allows for the frequency change to happen so much easier. So if I use one transistor, put it in there, and then make this thing run, I can use the RPM of the disk itself to run that DC flyback with that frequency of the RPM. Okay, just understand what that means. It means that if I'm not putting frequency into it, my plates that are moving are putting frequency into it for me, which means I have a very high amperage state and a very low voltage state going into each single plate, which helps when you go to convert an asymmetrical capacitor into a very high magnetic state in order for it to jump. Think about how that works there. You're changing frequency. You just need the energy to be there so that it's very low. And you got to remember how that works out. You get the low heated state in the center, and then it builds out to a higher, frequency, which gives you a higher energy state. Because you're dealing with the three plates here, it builds the bubble on the top, it builds the bubble on the bottom. When you switch to AC, it becomes one bubble altogether, and it goes to the higher level every time. It's an understanding we got from Gerald, and I'll just give him a shout out here to Gerald on that. He did a test when we were talking on a live once, and then he went back and did it the next day. Absolutely brilliant on his part and how he did it. He showed DC jump, okay, on his coil. Remember, in every one of his coils, he's got two coils in there. He hit the frequency on the second coil, jumped again, and then he goes, watch this, I got one even better. And he put it in AC, and it jumped right off the ring, okay? In that, he told you what the states were. DC is a holding state, okay, in a bubble. It'll jump the bubble again, okay? But when you put it in AC, it's a propulsion state. It'll fly right off of it. So he went through the states of how it actually worked. So very interesting stuff. There's a lot of conversion that goes on in the gravity flyer as well. When you look at the Tesla coil, what you got to remember is when you put the piezo up there, the reason that you match the piezo with the Tesla coil is because you're suppressing the Tesla coil. And here's what I mean by that. If you have a DC state in both plates, right, and it's creating those two right here, the way you get to an AC state is you normally bring a Tesla coil over to it, and the Tesla coil will take over and make it into an AC state, okay? Just like going back and forth with your inverter. Now, what the important thing is suppression of it. It's always suppressing the AC state until the DC state builds up. It has to do with how capacitors in AC and DC work, okay? DC fills it up, The actual piezo, because it's going at a different frequency, it gets a 25 megahertz. It brings the amount of voltage up much faster in the DC state, right? But then once it's full, you switch it to an AC capacitance by letting go of the suppression of the Tesla coil, automatically putting it into an AC form and creating the magnets that are on the bottom versus the plate above it, and allows it to jump up because you're in a bubble, but you're using levitation like a maglev in order to lift it to the next bubble based on that AC state. There's a lot of moving parts in here, and people would say, well, why don't you change the materials? It's because of what they're doing. You can't change one without changing the entire operation of this thing, but you must identify every operation. That's why we were telling you, hey, it's moving to the side and then it's coming up, moving to the side. Why? Because when he did his thing on how everything built out on his circuits, he put in there that the motors were connected to the piezo. Well, why? Because as soon as you turn off the ultrasound device, you're also stopping the spin on the motors. That means that instead of it moving one direction, it pulls back to the other side. Then you hit it with AC, it jumps, comes back, moves, and does it again. It's the exact configuration matched with exactly what he's doing in his circuits. That's why we're bringing it out.
Nathan, so I want to backtrack on what you
Go
said
ahead.
just a little bit, because there was something actually kind of significant that I think that you touched on, but maybe like we need to expand a little. So you were talking about kind of like the heat before an RF, right? Now, what's interesting about that is that the heat isn't there until you touch it. Now, understand that they use this medically, right? Like there's tools that use radio frequency to basically, cause burns, or, like an ablation would be a good example of that, where they burn out a nerve root using radio frequency. I mean, it's what they do. But the instrument itself, okay, in that case, is not inherently hot. It's hot because it's in contact with something. Now, what does that mean? Well, it's only part of the system. It's not all the system. And radio frequency is generally radiant, okay? But the fact is that when it comes back to resonance again, right? So whenever you have a system that's in resonance, okay, and it's building capacitance of radio frequency, which would usually just be thrown out, because it's in resonance with the rest of the system, it actually uses the other energy vectoring as a carrier wave, okay, to act like a current, even though it's not, okay? This isn't something we've ever said before, but this is just inherently true. Now, what happens when you take something that is not entirely in resonance with the situation, okay, is that you might not take in the current as much, but you immediately break through the least stable denominator of it being the radio frequency. That immediate and emergent release of the RF, okay, from the metal by touching something out of resonance, okay, is an immediate cause of heat that occurs. And the heat is quite a bit at that point, and it's real. But where is it? Well, it's generally not on the surface that it's emerging from. It's onto the surface that has caused the collapse of its resonance. Okay, it tells you a lot, because it tells you that you can take things that don't normally do that and cause them to do things that they don't normally do, but they'll always the tiger never loses his stripes. The RF wants to return to RF. It just needs the damn reason to do it. But what does that mean? Well, all that means is that these carrier wave situations in resonance means that you're stabilizing an entire ecosystem and environment, okay, into being closer to a state of rest, okay, than they are in ambiently. And because they're closer to a state of rest, okay, leaving it actually costs them more energy than staying in it. staying in it, so it's just following the very laws that they've all put down for us, where everything wants to stay in its lowest energy state. Okay, so because it's expending less energy, it's therefore in the less energy state also because it feels more at rest, even though it's doing more work.
Mhm.
That's what resonance does. And that's how it acts as a mechanism for superconductivity, is because it basically entices everything to say, hey, we're all the same here, and then everything gets to relax.
Yeah.
And again, that's like a quiet part that we never said out loud because we've talked about RF burns and so on and so forth, but we've never really said why that is. It's because it's riding on a carrier wave in resonance. There you go. There you
By
have
the, by the way, it matches that picture we put up of the sine wave.
it.
Think about it this way: at the bottom, you had a longer DC signal, right? So what does that say? That's your motors. That's the inside of the RAV. Okay, exactly how it works. And you go in. This is the same way you do your fists. Okay. Then you have a shorter one. Okay, what is that? That's your high voltage potential that's on the inside right there. Then what do you find? You find a sheath zone. Okay, that's actually the inside of your Tesla coil right there. But because it's connected to the aluminum, it's also your eddy currents. Okay, it's what gives rise to eddy currents being able to be in the air because it's in the plate, but then it's building out the field around it. That's what tightens everything in and holds it. That's why you use the aluminum. It's pulling it back in and holding it into a RAV structure. You have all the elements, the frequencies aren't tight. See, that's the difference between the RAV and the Gravity Flyer is the RAVs of frequencies are all super tight, right? In the Gravity Flyer, they're expanded out like this. So it's building the same field. It's just doing it in a different size, in a different, not in a different way because the structure is the same, but in how close the sheath zones are tightening in. That's why it's a low energy state lift. And you always hear anti gravity, low energy, three low energy states to make a high, to make anti gravity. Well, that's exactly true. It's because they're separated in the energy states and never brought into one and
Yeah,
just used that way.
and anybody who's been watching us for long enough knows that when we were first touching on these subjects, right, we were touching on it in a different context entirely. Okay, like the engineering aspect of it was focused solely and mainly on coils of different, geometric structure, sizes, resonance, etc. And one of the things that was a common discussion that we had back in those days that you don't really hear anymore is the fear of a cascading event, right? And what happens when you open up the point, right? And the energy comes pouring out. The question is never does the energy come pouring out and then it's like some kind of immediate situation or whatnot, although it could actually be terrible now that I kind of think about it. But the answer was kind of more in the context of, or the concern rather, was more in the context of material failure. Okay. Because with the way that the coil does it, you're trying to virtually create the cavitative effect. And if you were to open up the energy well there and it were to, back EM into your system, which it probably would, sometimes at least, well, then you fry your shit. And, like sometimes, as Nathan will tell you, fry it and find out. Well, I mean, how do you think you fry all that stuff? It's because you're opening up a cascading event, is why. And it's no different than when I was blowing up my PMPs left and right as I was, reversing the EM into, my circuit. Well, case in point's this. Why don't you hear us talking about something that we used to talk about so regularly? It's because the RAV has it figured out. You see, the RAV, like Nathan just said, it separates it. So, and then in the most extreme circumstance that I don't even think any of us, we could have theoretically have said it, but it would have been so woo, we would have laughed at ourselves and been like, yeah, and it probably, but you know what it actually does? It takes the highest energy state and literally puts it somewhere where you can't even touch it. You know what I
Yeah.
mean? Where it's like you can't touch it, it's there, but it's not. It's doing its thing, but like its access is super. restricted to the ratio and proportion of what you're creating. You know, so it's like giving everything that it needs and nothing more. So what you end up with is the situation where you could run way more current, or like what would otherwise cause a way higher temperature. You could run all these things without the material, like, failure. Instead, the worst you're going to get is material restructuring, which only in tune happens to the resonance of the system and the conditions that it's in to optimize what it's doing, which which is a whole other thing entirely. So it's really incredible that this huge concern that once kind of existed fell by the wayside because it got figured out by virtue of solving the problem.
Well, okay, so I gotta answer this real quick, Joe.
Mhm.
Similar to back EMF. Just let me explain this, and it's hard because the oscilloscope doesn't show it properly. Okay, if you have eddy current, it doesn't show up any different than magnetism on your oscilloscope. That's the problem. But if you can see back EMF for what it is, it's 90 degrees out of phase from regular energy. And I know that because when you go to convert it, you have to break symmetry twice. Okay, what does that mean? I'm breaking it down just like this. Boom, boom, boom. I'm breaking the symmetry in order to align it with the magnetism field inside the capacitor in order to use it as conventional energy. That means that you're getting different energy coming back off of it. That's why it's not usual for everybody else. They're looking at it as a non-magnetism state, which it is. But think about this. When we talk about weather patterns and everything else, we talk about entropy with it, we talk about temperature differential. It's exactly that state that you're looking for. That's what you're looking for. That's what you're getting out of the atmosphere. Okay? Why? Just think about it. It's a phase 90 degrees out because your magnetism field runs this way. Eddy current fields run 90% 90 to it, and you're at an angle. Okay? That's it. That's what you got to look at. You've got to put it in phase. That's what you're trying to do. Radiant energy is that field that goes this way on the earth. Okay, we've seen it in the RAV show up, and I got in an argument with Joe and Sean about it because they're going, Nathan, it goes this way, and I said no, it goes conventionally like we're seeing it, and they said no, it goes this way. I couldn't get my head wrapped around the single fact that it was out of phase. And once we drew it out and took a look at why, it made perfect sense.
Yeah, that's how it is sometimes because the again, this is where dimensionality comes in. When you're looking at the surface of something versus something that's below the surface of something, you can't look at it, for inside and out, right? It is automatically inverse, and it has to do with like a drive contact, right? And this was an example that I gave Nathan not even too long ago. I said to go this way in your car, which way do your wheels turn? Right? So your wheels turn this way for you to go this way. They go this way, you go this way. And this is how drives work, and the eddy
Yeah.
currents in that push out, and the magnetism, but are the driving force of the magnetism. See, the eddy currents are the um, thing that turns a magnetic component, being a rotational plane, okay, into a vortex, into a sphere, into a torus. It's they're there all alongside it. They're the ones that force the hand of the transition of the dimensional proportions and geometries of magnetism. And they go from the outside first, right, to the upward outside, but then they sweep. They cause what I've called the parabolic sweep, which is exactly what it is. And we've seen it. I have pictures of it in action. It's parabolic in its nature. It just goes, sucks up around. you have your center part, right? And then that ultimately, those inner fields and the separation, once the torsion starts occurring between the inside and the outside where the differentials are split, then they start counter winding against each other. That is the eddy current again. It's that counter winding that's going to pinch it off top and bottom, and then have it ultimately fall into place. And that's why I said to Nathan, I said, well, when you look at Earth and you talk about Earth's eddy currents and so on under the surface, the convection of Earth,
Mhm.
right? It splits, and I said exactly the way it splits and why and when. And I was like, it goes from 2 offset to 4, and then it doubles because it flips back around. And when it does that, then you end up with an equatorial plane with 2 halves, and then that split 2 ways to have 4, 8. So you have 8 eddy currents on the inside of a 4-dimensional sphere that is magnetism. And they're all driving forces, and they only have one common axis, and that's the direction of rotation. Every other axis is actually counteracting meeting and whooshing. It's that meeting and whooshing, okay, that is the belt pulling the wheel, of the internal geometries, okay, which are both internal and external simultaneously. Fight me on it if you don't believe me. It's the cause of the internal compression, decompression event of what you would consider the funnel of a torus, even though it's there and not at the same time, because you can have stuff inside of your sphere occupying that space as the torus is active in doing something else through tunneling events, because it is not 3-dimensional. All right. And that's it. And that's what's cool, is that it's here and not here. And this is what I've been explaining. It's very hard to get your head around. Something could be in your room, but it's here and somewhere else simultaneously. And if you put your hand into it, let's say, your hand is there, but it's also not there too. It's also somewhere else at the same time. It's crazy. It's just a whole different thing. And that's how things could seemingly occupy the same space, okay, or defeat a barrier when it just seems that way. You see, they're not actually. They're just using a different space that appears to be here because perceptually we have no other way to imagine it, see it, or otherwise, right? But the fact is that when something goes that way, it's actually not occupying the same location. Yeah, very cool.
Yeah. Sorry. I was reading the comments. Yeah, I think you're absolutely right, Joe. So I don't think we dissolve matter the way we think we do either. I don't think that works that way.
What do you mean by that?
Just because you don't see something doesn't mean it's not there in another state.
Mm-hmm.
We call it dissolving of matter, right? But that's not exactly true. It goes into a different state of energy.
Yeah,
So,
that's where the dimensionality comes into play.
yeah,
It's very interesting how I postulate it, right? When you break matter down, let's say you steal all its electrons and then you just leave it as an atomic mass of protons and neutrons, if that's how you want to think about it, whatever. I'm not getting into arguments over, we'll call it protons and neutron mass, okay? But low energy state atomic mass. All right. Well, if it happens in your room, okay, it falls into the environment, okay? It is at a lower dimensional, it's in a lower dimension, okay, and the same as energy gets trapped in the 3rd dimension, well, that matter is trapped in the 3rd dimension, okay, in that circumstance. But now, let's say that this happens out in space, okay, and the thing, it just goes into a state of fall where it's not in any field interaction whatsoever. It's got no ambient energy to excite it, and it's got no ambient matter to attract it. Okay. So there's no condensation occurring. At that point, I believe that it could achieve a state of rest and fall out of dimension, and then it would actually return to the lower dimension in which it, generally occurred in a state of rest, which is probably right back to the top of the scale, because the Ouroboros, like its mouth eats its ass. And we've discussed this. That's what the dragon likes to do. He likes to eat his tail. So, I mean, and that's probably like kind of once it falls off into a state of potential and non-excitation with nothing to accumulate to, I think it ceases to exist at that point. But if it happens in Sean Calderon's, workshop, well, I mean, there's a lot of activity and stuff going in there. There's air particles banging into it. Chances are it's never going to reaccumulate into matter. Chances are nobody would ever detect it as anything that it actually is. It's literally just, nothing at that point. But like it would still have quasi instances of excitation that would keep it observed, right? Environmentally observed. So, it would probably just exist in that fashion indefinitely.
So I got something in my head, Joe. I'm sorry.
Yeah.
What about, okay, because this has been observed from Ralph Ring, and the craft was there, and then it went into a different energy state and it was gone, and they couldn't control it anymore to bring it back. Okay.
Mhm.
So my thought on it, okay, is it just played with the time dilation field, and it appeared at a different time than they were in. And when it did that, it hadn't emerged into our time yet. So therefore, how do I say this? It lost all of its ability to propagate in our time in where you are in that room. I don't know if it sounds right or not, but in
It does.
itself, it's whole where it's at. You know what I mean? It's not dissolved. It's not gone. It's just there. It's in a different locality of time. Does that make sense to you?
It absolutely does, and that just has to do with phasing, and that's again what it is. If something primarily exists out of phase, it could be fully there, and if it's of a higher dimension, right, that means that we are part of their there. Okay, so if something were to come into phase with us, it could be here, but it could easily just leave back to there out of phase, because we're only a small part and makeup. We're a piece of that upper reality. You see, it's no different than a molecule being part of our reality, or any piece of matter being part of our reality, the building blocks of it. Like our whole entire three-dimensional existence is simply a structural component of that upper dimensional geometry. Okay, so it just simply matters as to the phase that you're in. If you're in that phase, nobody's saying that matter can't exist in that other phase.
Mhm.
You see, like this might be the inherent equilibrium state, okay? But as you well know, like as we've discussed before, not everything is in that equilibrium state, and that doesn't cease to exist either. Matter could exist in a higher energy state. Chances are it would just simply be under a constant state of flux. That's sort of it. I mean, and weirdly, if you're there, it's like what that flux would be is you actually trying to be kind of brought back into the third dimension. That's what that flux would be. It would be because you're kind of tethered to, so you want to pull back into that phase. But the weird thing is that since this existence is just a building block of that existence, I mean, without going into some crazy, theoretical shit, that just means that, well, simply there could be other parallel existences, right, that exist in that phase that could equally want to attract you too, because it's just simply a building block as well, and that you could just be a part of. So you'd probably be there and constantly be in a state of trying to get sucked into some other, um, you know, phase that's more coherent with your initial phase.
So, okay, how to say this? Can you imagine being in a dogfight, right? And you're coming up on this ship, and then it phases out. It stays where it is, but you can't get to it. So you go right through it, okay? End up on this side, and it phases back in behind you because it's in a different time.
Mm-hmm.
And then it takes you out. Can you imagine the advantage in that? That's amazing.
Well, I mean, that was Philadelphia experiment all day. That was everything to do like, and honestly, um, phase, just dropping something out of phase has everything to do with resonance. So all the density level shit that we talk about, the differentials, this and that, mind you something, there's all sorts of differentials, and you really only have to separate, I think, three pretty much, right, in order to break out of anything. And that's because everything, all the differentials are three, and that's why it's kind of 3-6, right? So if you influence your frequency, you're influencing your oscillation, which is analogous, but in a vibratory sense, and then you're also, challenging the sound at that point as a result of that vibratory oscillation. So now you have an electrical frequency, a vibratory oscillation, and a pitch. Okay. And then you have your differentials of them set off. The differentials get in the state of non-equilibrium, like the RAV, and then that ultimately opens up the door out. So now all you have to do is fall into full-blown resonance to become part of the exchange. And then once you're part of the exchange, there you go. Now you're on the other side. But remember, it's going to want you back. Okay,
Yeah.
so it's probably trying to pull you back pretty much the entire time. And then chances are, whatever resonant state you induce once you're in that other side of the veil is likely to become of what you're attracted back into. And I don't think that these differentials are that extreme to reach because, like I said, it's a proportion of the whole, okay, based on your immediate locality and what it is that that you're building the field around that it's subject to. So it's not exponential, okay? It's actually proportional, so it's a small proportion of the whole, and those are the set of differentials that you have to break.
I think, okay. I think it's when it breaks a Springer limit and it goes into Planck scale or beyond Planck scales when you start to get the time that happens. That's kind of where I'm at with it.
That's
Yeah.
exactly what it's always been. But you can manipulate the nodal and antinodal points.
Mm-hmm.
Okay. And the way to probably do that is with a DC pulse rider on a sine wave, because if you're able to pulse rather than mid sine, if you're able to pulse at the nodal and antinodal points because they're riders, if the duration of the pulse is longer than the nodal or antinodal point, one rides the other at that point, and it'll actually expand the time that it's at that fixed energy state that would be the otherwise the turn. So you're stopping it at the point of the turn and amplifying it and then holding it. All right. So it would go, you know what I mean? But because you went, instead of it going like, right, where you would have to hit it at exactly that moment, because you held it open and held it at that tonal frequency. If you take your out path at that point, it's basically holding open the moment when the pendulum is stuck up, before it starts to swing down. And then as soon as that DC drops off, what does it do? Swing down, and then it's closed. You see? So that's how you pull your nodal point open, is with a DC rider. It's got to be, I would say, a resident DC rider. I just make shit up as I go along, as you're aware, but I wrote an entire physics paper that was written exactly that same way that I strongly advise that you read.
I did read it. So okay, there's always something that got me, okay? Remember, they talked about the U.S. president that met with aliens, supposedly. I put it out there, and I don't know if it's true. Was it with Eisenhower?
I
And then, yeah, and then they said they're from Venus. Yet, we saw in the 60s when the Soviets landed their satellites on Venus, they got crushed immediately. There's no habitable zone on Venus at all. So, they always talked about this. Are aliens time travelers? Are they actually us? So that's why I asked the question. That's kind of the premise of it. If they're from Venus, then they would be in the future because they would be pushed out further to the Goldilocks zone of where Earth is now, right? Therefore, their whole thing would change. They probably might grow a satellite out there, get a moon to it, based on when it goes through the energy field. So, would they be from the future? Is there a chance that they're underground and survived all that pressure? I mean, what do you think about that?
I mean, is there a chance that they're just from out of phase, where they're from Venus out of phase, which is
No, I didn't think
not
about that.
not the same Venus that we perceive here? Because realistic, what's weird is like like there could actually be everything that has like, and this is the idea, right? There could be a totally different situation going on right now as we speak, right now where we are, okay, on a different channel. Okay, and that's kind of what's weird. And on a different channel, Venus may well be perfectly cool, you know, like it might be totally habitable. Earth might be too. There's probably a channel for that where both Earth and that are. So you look around, you're like, where the fuck is everybody? Or why, oh man, why is there remnants here but no sign otherwise? Well, what happens if their remnants is partially in phase with us? Okay, but the remnants is actually more complete, just in another phase. Yeah, it sounds like a multiverse, but at the same time, it it kind of is and isn't at the same time. Is the point? Like, because if you can, okay, first of all, I want to put something out there, and I think it's important to say, given the subject matter of today. Okay, if you're three-dimensional and you're four-dimensionally accessed, all right, and you're there, you may perceive no time, okay? However, that does not mean that the fourth dimension is not subject to time. See, there are more than four dimensions, and every single piece works on the other. And this threshold boundary that exists, okay, actually goes up in orders of magnitude the higher up you go. So what that ultimately means is that the fifth dimension on the fourth dimensional threshold has a huge time barrier that exists there too. If you're in four dimensions, it's just not in phase or in sync with what we're doing down here at all. So it's just a matter of perception at that point. Those years could turn a lot faster or a lot slower. I mean, probably a lot slower, to be honest. Like they're torquey. The upper workings of things are the torque. Things get geared up as they go because they become smaller and smaller bits, right? So you could turn a big piece very slowly, and if the next one is only a piece of that, a fraction of that, then that means that next one's going real damn fast. So the cycles are much faster as you drop down these dimensional ladders. But that doesn't mean that the fourth dimension has no time. That just means that their time runs it's out of phase and runs at a different type of relative speed than we would conceive. Which to us would probably appear at a standstill. Because you'd be looking at Earth and you'd be like, wow, all of Earth already happened here. Okay. Oh wait, which version of the Earth? And yes, it does sound like multiverse, but it's kind of not. It just, again, has to do with channels and phase and resonance. So yeah, everything is probably a slightly different pitch, and that's how that goes. Because I
So
think at the end of the day, it boils all down to sound, no matter what anybody says.
speed is relevant to us because time is relevant to us.
Because it's the measure,
But
exactly.
but
And
to
that was
them
something
it's
we were
not.
thinking before.
Yeah, but to them it's not. So the speed on Venus may not be the speed on Venus to them. It may be the same speed on Earth. You know what I mean? To how they perceive it, and that's in the different dimension that they're in. We're seeing it as faster than it really is.
Right. Well, the other thing too is like when I said it goes down, right? It goes faster and faster as you go down. But when you start looking at stuff like radioactive material, and then you realize the decay rates, right? And then how the decay rates are actually occurring because it's actually reducing its dimensionality and releasing something, right? And it's in our dimension because it makes up our dimension. So we perceive that time pass, but that's actually happening much, much faster on those other levels. See, it's in a state of instability. And as far as that perception of time would go from that level of things, that fucker runs zipping fast. Even if it's got an atomic half life of like, a million years. It like to us it's the million years, but that sucker's unzipping fast as far as it's concerned. It's throwing radiation left and right as far as
Hmm.
it's concerned. That's just because of its vibratory rate that it's at, its state of instability, and the fact that it's um downgrade, it's reducing in its dimensionality. The same as the 4D stuff is coming down to 3D. That's why there has to be an exchange rate, which is exactly what I put it, which I said was the mechanism of time. So just the same, when things are falling out of 3D into lower dimensional proportions, well, there's an exchange rate there. Well, we know that exchange rate because it has to do with radiation.
Hmm.
And even if the half lives are different, there's certain factors within that could be taken out to show that the exchange rate is actually even.
Hmm.
I'm certain of that part, and I just don't have the math to show it yet. But if you prove it down, it's a lot easier to prove up.
Oh yeah. Okay. I just find it an interesting topic, and I know everybody's got their own way to see everything, and I just find it interesting. I was watching a special the other. Can you see Apollo 12's landing site on the moon? So they went over there and they showed your conventional telescope and know it's too small to see it on there. Then they got a better telescope and then they could make out a flash of where it might be. And then they got something like NASA would have and looked at it and they said, oh, there it is. But it was so small, it looked like a little, I'll say this, it looked like a little toy on the ground. So I couldn't tell the difference between it being somebody had a mat that looked like the lunar surface and a toy being on the ground versus if it was real or not. So in the end, the picture that they gave us wasn't any better than what we get from a regular telescope. I just thought it was funny because I always wanted to see that. Can you, if they did it there must be evidence it's there. But we take such crappy pictures in space, we wouldn't know.
Yeah, that's true. I mean, the weird thing is that this kind of makes me think of like Schumann's resonance and just how it's so low and stuff. But I just want everybody to think real quick about how this phase stuff actually makes so much sense that it's insane. Okay, because first of all, you're on Earth. Okay, you're standing on it at all times, or you're within its field if you're like not on ground, I guess, right? But you're always in constant relationship with the surface and the atmosphere of Earth, which is subject to this energy exchange between it that we see, we know exists. It's common knowledge, right? So the energy exchange exists between our atmosphere, our magnetic field, and the Earth's surface. And I hate to tell you, but the core, down all the way to the core, is this relationship, and you are an intermedium in this relationship. and the measurable oscillatory rate is subject to that beat frequency, which is measured as Schumann's resonance. And if you've ever sat on something that's shaking for like a while, let alone your whole entire life, right? You know that when you get up, you still have that shake in you. All
Oh
right.
yeah.
It doesn't just simply go away. That's because you've been induced, okay, from whatever resonant, oscillatory resonant state that you were in into something in sync with that. And then you held capacitance of that because you don't just fall out of it, because the amplitude of it is actually stronger than the ambient of the Schumann's resonance. It actually has an offset that you're sitting there shaking at, and there you go. That's what's going on. It's crazy, right? So you spent your whole entire life on this damn planet, and you're obviously constantly shaking, okay, at the same exact rate, minimum plus your own, all right, as Schumann's resonance. But you can't shake the fact that Schumann is through you all the time. Now, what happens when that number starts to change? Well, when that number starts to change and the resonance change and everything, first of all, it gets ill affected at first because a change of resonance, okay, that's not proportional, okay, in the exchange will make you feel off and make you change, probably genetically and all sorts of different stuff. But propose it happens over time and generations. Well, are you even in the same phase if that number changes enough, okay, as your ancestors were?
Mm.
I don't really know the answer to that one. There's
Oh,
a chance that the answer is no. So what does that ultimately mean? Oh, well, that means that if you just went out of phase of them, okay, that this time could actually loop, and it could be looping on resonance, okay, and that we're actually occupying the same time on repeat on the same surface, okay, but the only difference is we've fallen out of phase of them, okay, and as there's still elements of what the ongoing is actively occurring with them here at all times, like dead ass serious, but it's occurring for them as it was for them then in that phase. That might sound batshit crazy. It might sound like lunacy or whatever, but something could be both appear in ruins and simultaneously active and working at the same exact time, because it's sort of like if a VHS tape were to like run out of film and then rewind back to the beginning, start recording over, but rather than rewrite and erase what's in front of it, it's just rewriting on top of it. You see, it's like a
it's
CD, like how it does that job,
but
where it stacks
it,
the writing.
it's the Roman soldiers in the basement.
It's the Roman soldiers in the basement, right? See, so it's not that it's not. So that's actually happening, not then, not there, but here and now, and the
But
phase is close enough for the observation in that case.
that's that's really cool way to think about it. You know what I mean?
So is it like, that's what's fucked up about time. And that's why they say, like, well, you could see all time at the same time under those circumstances, is because, like, we see time as a straight line, but it could well be just looping around and around on top of itself, rewriting over itself just constantly.
So that
And
thing in the
it's based
Vatican,
on resonance shifts.
so the thing in the Vatican that showed different spots in time. I mean, that little TV screen that they had, that could actually be true.
Yes.
That's amazing. Man, that's a wild one to think about, huh? You can go there and see all the events of everything.
Yeah, I mean it's craziness. You just got to tune into the right channel. It's for all we know, it's all here, it's all now. They say there's no time like the present because there is no present.
Well, I'll tell you this: if that's all right, then what Eights always said about time is true. That you can change time, you just can't physically go back in time. Like you can't. Excuse me, let me rephrase that. you can go in time, not change time, but you can go in time, but you can't interact with time. So you can view it at any point. That's
So that
interesting.
so that's part of my equation, okay, is irreversibility, right? Meaning that there might be a certain finite amount of actual backtracking that can actually be done, but probably only in a virtual sense, right? And that is the virtual sense. Now you could, and again, it becomes an entropic equation, right? Like you can't go back in time, but there's potential that if you're able to tap into um specific frequency, and this is not, by the way, in the paper, this part, right? If you're able to tap into specific resonant frequencies, let's just say of the past, okay, that is able to um bring factors of that into the present as it's kind of still playing and playing out. Well, at that point, you could potentially put retrocausal, oh, well, there's the word right there. You could potentially put retrocausal action, okay, into play, which would then only do one thing, which is it would auto correct itself through, because it's, again, what does Rav do when it starts to run low on energy? It pulls from the well,
Hmm.
right? So there's like this auto balance that works off of the ratios, and it might change things, but you'd be none the wiser because the change would just be, you know, in, like right then and there. So you might not be able to go back, but you might be able to tune into an influence, which kind of is scary and crazy when you think about it. But the past, that means that the past could do it too, which is a whole nother, which is a whole nother story. Um,
I just
yeah,
think it's cool because it opens those doors once you get into what things actually do. So you come out with your paper, you show what's going on, right? But it opens that door directly to can you see what the past did? You know what I mean? That's interesting.
yeah, yeah. I mean, it's very interesting too, because like if you think about like and none of this is in the paper, I would never put it in there. But if you
Well,
think
we
about
understand.
metaphysic, implications of it, well, that means that when you are able to undergo the processes I previously described and stuff, things like manifestation, okay, become a lot more realistic, because if you're able to be have an open portal more or less to the energy realm, okay, which has the full spectrum of time and space in front of it, if the the feedback loop is good, right, then ultimately it could pull things and energies and yourself in certain directions, that would actually lead to you coming, into a circumstance that would allow for the things that you sort of envisioned in that circumstance. And unfortunately, people do this all the time. And I say unfortunately because the people that are best at it and most effective at it, okay, they don't know what it is or realize it exists, and they're miserable people, that think that everything's a problem, and see a problem where there is none, and so on and so forth. And then all of a sudden, all the bits and pieces fall right into place for them to cause the exact problems that they anticipated, even though there was no indication of them whatsoever. And they
Hmm.
do it all the time, and because they're so powerful, because they don't know what they're doing. They know no wiser. They don't know what they're doing. But like, it tends to be, in a world that seems punishing from at time to time, it tends to be difficult for people to be delusionally optimistic. You know what I mean? So, when you tend to be delusionally optimistic and you only choose to see the good things, and that's the energy that you put out, et cetera, well, all of a sudden, things start to fall into place where, like, you could see these opportunities, you take these opportunities, and then all of a sudden you look around and you're like, holy shit, look, something's different here. But,
Yeah.
like, you have to believe your own bullshit is what it boils down to. And there's just a whole handful of people that believe their own bullshit, but not the right bullshit. Like a whole bunch of them people. I've seen them ruin all sorts of stuff, right? Right at their own will.
Okay, Joe. We're getting towards the end of the show. I want to share a couple things real quick, if that's all right.
Right on, right on.
This is Dennis's experiment.
Ah, cool.
Telling you about the beginning. Look at that where his finger goes. Dude, I'd literally play with that thing all day.
They look like symbols.
Yeah, he's got like electricity on his fingers the whole way down.
Oh my god, I have bad thoughts. I'll say it when I'm done.
That's really cool, man. I'd love to build something like that.
All right, Dennis. I know you're watching. I don't know that I'm recommending what I'm suggesting, but I'll let you be the big boy and use your best judgment. Take a secondary source, okay? I want you to hook a ring around your finger, okay? And hook your secondary source up to the ring. And then I want you to do it, but at a little bit of a distance.
Are
Because
you
you know
trying to
what that would
kill
do,
him?
don't you?
Uh-uh.
That would form a wrap.
Oh, wow. Okay.
Probably a very small wrap, but that's what it would do.
I like this one, Dennis. He's good. Let's see, he's got another one. Oh, look at that.
Yep, that's working off of capacitance.
Yeah.
I always like that. That's always a nifty trick.
Yeah. That one's cool, man. All right. That was cool.
Mhm. Man, he's getting a lot of UV out of that.
Yeah.
That's a more like pure UV than we usually get. This is
What is
like
it?
running a spark gap.
Yeah, he's got a spark gap going on too.
Yeah.
I gotta
Yep.
give
There it
a
is.
I gotta give a shout out to Courtney Sam's. He has a Tesla coil right now. Okay, you saw the big 9 foot Tesla coil, the gigantic one, and I went out there and saw it with him. Okay, now he has one with a load on it, with another coil on top of it, with another load. Okay,
Courtney, you're holding out on us, dude. How come you haven't been on the show yet? And how come you haven't had a demonstration? I'll
oh,
never know.
we're gonna go. We're supposed to go when crypto came down and go over at night and to see it, but crypto hasn't come down yet. So, it's not Courtney's fault, man. It's
No, I
us.
know. I'm not breaking Courtney's chops, but I think if anything, we should have you on one day. I'd love to hear about your story of how you even got involved in this.
Yeah,
I
dude,
wonder that sometimes myself.
dude, I had so much fun there, dude. It just lighting up stuff at a distance, man, is so fun. It was an awesome day, brother. We're definitely gonna have to do that again. All right, guys, I got something for you here, and it's okay to laugh or whatever you want. I just thought it was awesome. I'll show you something happened the freshman year of my life. So if I can find it here real quick for you. And you can feel free to figure out which one I am on this. That's back when we did the backyard wrestling, man, at my buddy's house.
Oh yeah. I see you used the Joe modified one.
Yes.
Yeah.
Yes, I did.
That came out pretty good. Not too bad.
Yeah.
I see myself a bun.
Yeah, it wasn't fat back then. That was nice. You know what I mean? Oh, man. Yeah, you guys can figure out which one I am and that and everything else. But yeah, freshman year, man, we all got together and hung out and did backyard wrestling, man. All had different outfits and everything. And well, I'll wait till people figure out which one it is. I'm not the guy with the boas, that's for sure.
Yeah, that's Santa Boa.
No, not that one. Oh, man. You can't see it. Well, you can probably see it now.
Aaron says, "Well, Joe is Santa." Actually, well, when you're done with this, you should show him the one of me that I sent you in return. That way you can make fun of me.
Oh,
What a fat shit disaster I have.
fucking funny, man. I'll pull that up right now while we're waiting for the comments to come in. I think that thing's on a lag. Dude, it's always fun, man.
Oh yeah, no, this is good. I mean, clearly Nathan is the one squatting in the middle with sunglasses on. that was in his 8th grade days, you know. he was going through a phase.
Yeah. Oh my god. No shirt in the middle? No, that's not me.
Bueller? Anybody?
White tee in the back row? Well, I'm in the back row, that's for sure. Don't have a white t-shirt on, though.
Well, you
The
narrowed it down,
Backstreet
didn't
Boys.
you?
Yeah. Wearing black? Nope. Wasn't wearing black at all.
Nathan went from Puerto Rican to an Italian. Same thing anyway. I'm allowed to say that because I'm mostly Italian anyway. God.
Oh, man. That upper left, that's me. I wore the white singlet.
Yeah, Nathan.
Doesn't look like a fat old man, does it?
Yeah, your face really didn't change that much, though.
That face didn't change. I had my hair up too. It was down past my shoulders at that time.
Yeah, right up. I'm gonna have to superimpose a beard on you there so everybody can see the resemblance.
Yeah, put a. Well, I told my wife the other night it was just proof that I was skinny at one time. She goes, "Nathan, that man doesn't exist anymore. You give up on that thought."
Well, after today's episode, you just have to say no. He does. Okay, he's just out of pigs.
There you go. She'll probably ask, "Well, when does he come back in phase?" Because I want to see that guy tonight.
Yeah.
Oh man! All right, that's enough making fun of me. We'll put up Joe here.
Oh boy.
We'll give him a run. This looks nothing like Joe, by the way.
Look at which one I was. Which one was I?
Well, the only one there.
I'm the only one there. Shit.
Oh man, this is 70 years ago.
Yeah.
Oh man.
Man,
So
I
funny.
had to dig into the well of shit to find that picture.
Joe's actually in good shape there too.
Oh, I was in good shape there. Yeah, man. I probably didn't weigh too much less there than I do now. The only difference is it all
Muscle.
It went all the other way. No, I was like 22, 23 there, 22, something like that.
Oh man, we went through the time travel of life, and you changed structure. You went from muscles to fat everywhere. That's what I did.
No, yo, that's how I got all my brain cells is to work so good. I just like, you know how your brain's mostly made of fat and stuff. You know, I just like burritoed my way to intelligence.
Burrito. I love it.
Yeah, burritoed my way.
Oh man. You got to
Yeah,
be able to laugh at yourself, man. I think it's pretty cool. You know what I mean? Back in the day, everybody was in shape, but now we're like, well, getting to 50, getting can't keep that structure no more.
that's all right. You know what? I'd kick the young mind's ass.
Yeah.
Dead ass, yo. I got piss and vinegar in me sometimes.
I tell you what, man, I would get a couple good swings in, and then my ass would fall out tired and get kicked. You know what I mean?
Yeah.
Yeah, we all think we can do what we used to.
Nah, I mean, it shouldn't probably say this all too openly or willingly or proudly, but I mean, you know, I never really liked to, you know, get physical with people, but for some reason, man, people used to just like to find reasons to like find a good reason for me to have to knock them the fuck out, and that happened more times than I could tell you, man. It is, I don't know.
Well, that's because, well, look at you. You look like a cop. You're
Yeah,
like off duty or something. Like, hey, I'm going to the shooting range. I'm off duty.
actually, that's what I was literally about to go on the tactical training course. That's why I was
Well,
wearing. That's why I was wearing a tac vest.
yeah, well, you got the glasses for it. You know what I mean? And like the not all the way shaved beard. Yeah.
Hmm.
Oh, it's funny.
Yeah, good times.
He says ICE interview.
Yeah, for real.
Oh man,
Man.
love it. I gotta know we have a good time on the show, man. Just
Yeah.
having a good time. Uh, I just found it was absolutely funny, man. I didn't think I was ever be able to find a picture of myself that young. You know what I mean? So
Yeah, and yeah, I'll tell you, the photo restoration stuff is really cool. It really helps. You know,
oh
it
yeah,
not it brings it like back to life, man. It's like I've been really digging that. You know, so
yeah.
I've been doing a whole bunch of weird art stuff lately. Pretty cool stuff.
I'm gonna have to see if I have one in my senior year when I was doing wrestling because I stacked on 30 pounds of muscle at that point. You know what I mean?
Mm,
So well, a little bit of fat with it, not much. So I actually graduated at about 220 pounds, man. Stayed that way until it was about 8 years ago. I started gaining weight. So
yeah, yeah. I was probably like 190 in that picture, 185, 190, and I just didn't have a drop of fat on me. So it was a different time. Sideball. Yeah, thanks. I actually, you know, it's funny because I was supposed to be a cop. I come like my whole entire family's cops. You know,
oh really?
yeah. In fact, they like not only influenced me to be in that direction, they pushed me to be in that direction, and I passed the test, got called, highest salary, you know, cops in the United States, like top five, both of them, and I said I don't want to do it. Didn't want to do it. You know why? Because the
Why?
same reason this is crazy how certain things and people don't change. And sometimes you say things that you know you feel, but you don't know exactly the full extent or why yet. But I said, you know, I know you get to help people. I know you get to do the right thing or whatnot. I was like, but I also don't want to be the person to intervene in somebody's life, have stories, and change somebody's life forever just because I have to. And I was like, you know what? Necessary job to exist, but not a necessary job for me to be the person to dispatch that. And
Yeah.
that was my take was yeah, you help people, but guess what? You get to sit there and take a lot of people on other people's words too and screw them all up two ways to Tuesday. And I just wasn't willing to be a part of penalizing the innocent, you know, just to sit there and, you know, take in the guilty. So
Well, think about that. I mean, you go to break up a bar fight, right? Everybody's all done. They're sitting at the bar drinking together, and they probably are willing to pay the tab for anything that was broken, right? But as a cop, you have to go in there, and because you were called, you have to identify what the situation is and take them in anyway, even though it's resolved already. You know what I mean? And
mhm,
then it just means 5 to 10 years of garbage for everybody involved, and that would suck because yeah, you'd have to ruin somebody's life even though they squared it away already.
exactly. And, you know, sometimes non-intervention is the best intervention, and part of freedom is living with the risks of it. You know, I feel like, and obviously that doesn't mean that crime should go unpunished, you know, or, you know, on just whatever. But like I said, there's people for that, and those people have different personalities than me, and I'm not one of them. So, you know, like to each his own, you know, respect to the people that go out there and do it. But I also understand that the way that understood even at that young age, that despite a tit job with that was relatively safe and very high paying, and I could have been retired with a six-figure pension right now from it, doing something else that I actually want to do, and wouldn't have ever ended up in trouble, etc. At any point in time, you know what? Like it's just simply for me not worth it. Like, you know, the means doesn't justify the end. So
But it's good that you knew that up front. So
that's it. Leave me out
cool.
the process, fellers.
Okay, dispatch was asking if anybody had a prediction for what's going to happen in the next year. Please give it to them, send it to them. I'll get a hold of Limited State myself. I talked to him yesterday, and I'll get you that prediction, dispatch.
Yeah. I gave my prediction. I'll tell you what it is. So maybe that'll inspire some of you to think along different lines, you know. But I said that by the end of 2025, whether or not it's true or correct, I believe that there's going to at least be someone out there of notoriety, okay, who claims that a specific AI model, okay, has reached at least a form of AGI.
Hmm, that's
That's
a
that's
good
the
one.
thing. So I think that by December of 2025, somebody's going to say we have a model. This model's AGI. You know, now again, whether or not it is, that's a whole nother story. But somebody's going to claim it.
I'm gonna just go out there and tell you by the
Oh,
end
2026. Yes, I don't know what year we're
26.
coming into. Yes, that is very fast. Like they
All
better get
screwed
their
up this year, huh?
they better get their ass in gear if, if my prediction is going to come true. Now, yes, 2026.
I give you a prediction, and it goes with my work. I'll just tell you either that gravity flyer is going to lift or you're going to see it in pieces. That's the end of the story. It's going to happen this year. Excuse me, this upcoming year or not. And I'll tell you what, I'll make it fly. I could throw that sucker like a frisbee. We'll see how far it goes, but that's my prediction. Either it's going to fly, it's going to come off the ground, or it's going to be done. So
If
that's
that thing doesn't come off the ground soon, I'm quitting for you.
it's dude. It's been too long. It's got to go, brother. But the I think we're going to still learn a lot from it. I'll be very honest with you, but it's one of those personal things. It's been too long. You know what I mean? I don't like things sitting around that long. I got to get it to either work or do something at all. I'm going to put a lot of resources into it to find out.
Yeah.
So
And I mean, if I had to make one more prediction, and this is more of a close to home prediction as far as stuff we're doing, I think that with the RAV, okay, I think that by the end of next year, um, at minimum, we would have figured out how to create basic structure, you know, through modulation. That's what I think. I think that we're going to be able to take the controller, bring the parts together, create a modulation, and then be able to actually have a verifiable, um, you know, transmuted crystal process. And it
Well,
might not
dude,
be all that, but I think that by the end of next year, that would have been achieved.
okay. It's like that new movie, Tron. The way that they actually took that thing that was in how do I say data form and then made it into the people and everything like that in the number three version they just came out with. That's gonna be kind of like it is. You know what I mean? It just prints them, and then they're alive and everything else. Dude, that'd be radical. I don't
Yeah,
know that I'd like police like that, but it'd be radical to see.
I mean, yeah. As far as like our involvement in such an endeavor, I think that having a handful of spots on a piece of intermedium that show a definite crystalline structure of something that wasn't necessarily there before, I think that that is probably achievable. And I'm going to say by the end of next year, but chances are likely at the rate it's going, probably like more like third quarter next year. And the only reason I don't even say sooner than that is a couple things is that the experimentation has been like a little dispersed, as far as being able to achieve these ends. But also, what I know is that every single time we make the next huge discovery, it opens up a whole nother can of stuff. And it's not necessarily stuff that has to be overcome as much as stuff that has to get sorted. So,
Hmm.
you know, I think that that's sort of what we're into. It's like, well, once you bring that cathodic dendrite on the other side, okay, of the intermedium, right? Now you're able to tunnel it through and get it on the other side. Well, then how do you get it to then grow volume
Hmm.
in volume? Because right now it's not growing in volume; it's just growing in a plane. So whatever, one thing at a time.
Right on. All right, man. I think we're about the end of the show, Joe. It's been 3 hours today, man. It's been awesome. Um, guys, we are going to do the show instead of next Friday. We're going to do it on Monday. Friday is the day after Christmas, so guys, we're going to do the Monday show, and then I'm taking the rest of the week off. I need some time. So it'd be kind of cool, man. We'll do it on Monday. Joe and I've done it before on Monday, man. Hopefully Bernie doesn't come on and turn off our show again.
Ah, Ernie.
got,
Oops,
got, got, got,
sorry.
Gotta give it to him, man. He did it to me twice. Sorry, Bernie.
Yeah, no peace and love that day. Oh well. But yeah, no, that'll be cool. On Monday. I can't wait to see Nathan and Bernie actually get together, and then he can end the stream as Nathan slapping his hand because then that'd be there. That's like a fail safe for that. Um, and yeah, aside from that, want to wish everybody a Merry Christmas and whatever else, I guess. Mm, yeah, man. Right on. Oh yeah, and I sent Nathan the paper that we've talked about today. I'll have him put it as a post on the channel, with like
Oh
a
yeah,
thumbnail or something like that. That'll, you can click on and view it, and we'll figure out how to do that.
yeah, not a problem. We'll put a
And
link to it
try to
in
make that
the
available tonight or tomorrow or whatever.
whenever you post it. We'll put a link to it.
Right on.
So we'll do that absolutely. All right, guys. Then I just want to say thank you to Darren out there. He gave 5 Old Man Builds memberships, man. Absolutely awesome, Darren. I really appreciate it, man. And good luck on everything from the surgery. I hope you do well, man. Best wishes to you on that.
Right on.
And then, guys, tonight, Mike Faraday channel, he's going on in the next hour, I believe it is. And he's got a cool thing over there, and he's upgraded his battery. So he's going to be talking about that over there on the Faraday Research channel. I'm also going to be on Traveling Fools later at 7:30. So it'll be on this channel, also streamed over there. So we should have a really fun night over there as well, man. Doing a little anti-Santa over there, getting ready for the holiday. But that's it, man. Everybody have yourself a great day. Thank you in the chat, man, for listening to us, and it's been awesome.
Right. Merry Christmas.
Merry Christmas.
old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put him in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.